All right. Welcome, everybody, to Standing for Truth. My name is Donny Budinsky, and this is Sam. We are your hosts for this valuable two-part seminar that covers the incredible scientific evidence supporting young Earth creation. This also includes debunking challenges to the young Earth creation position. On Standing for Truth, we uphold the truth of biblical creation. This is exactly what we are going to be doing for this two-part seminar. It is a privilege to again have Dr. John Gideon Hartnett with us for this important seminar.
Donny, I'm excited for this. I've been waiting for this. If you are skeptical of the young Earth creation, the position clearly taught in the Bible, and you are open-minded, then you might just be convinced of its truth after watching this epic two-part seminar event.
Sam, I'm pumped for this. Part one will feature several amazing lines of scientific evidence that powerfully confirm the truth of biblical creation. Now, these pieces of evidence include the decaying magnetic field and addressing objections to that point. Carbon-14 in samples claim to be millions of billions of years old. C14 simply should not be found in these samples that Dr. John Hartnett will be covering. Dinosaur soft tissue and more. This is going to be comprehensive, everybody. Now, we are also going to be engaging with key challenges to the young Earth creation model. And specifically in part two of this seminar, we are combining everything into one. And so this is going to be an information-packed event. Part two of this event will focus on the creation model in general that Dr. Hartnett will be covering. And so, Sam, would you do us the honor of giving our speaker for this event, Dr. Hartnett, a formal introduction?
Absolutely. Dr. John Gideon Hartnett is an Australian physicist, cosmologist, and a Christian with a biblical creationist worldview. He has a PhD with distinctions in physics from the University of Western Australia. During his research career, he worked at UWA and the University of Adelaide and published more than 200 papers in scientific leading journals, in book chapters, and in conference proceedings. He was a founding director of an Australian startup, now commercializing his research in ultra-stable cryogenic clocks. He has lectured around the world in churches, at conferences, and written extensively on biblical creation, most in terms of astrophysics and cosmology. And he blogs at johnhartnett.net.
Sam, I appreciate that introduction, brother. Dr. Hartnett, it is great to have you back with us here. I want to say before you give your own introduction that I really appreciate all the work that you do upholding the truth of biblical creation and also upholding the truth of Christianity in general, and the work you've done to prepare for this epic seminar. And so the last time you were here was for, in many ways, a seminar on the Big Bang Theory and why it doesn't work. That was a really good program. And so, Dr. Hartnett, how have you been since then, brother?
Yeah, good. It's been it's good to come back again. Just as a point of correction, my blog is johnhartnett.org.
Which, my mistake.
Also, BibleScienceForum.com. It's the same site. Yeah.
And if I could recommend your forum as well, people go check out, sign up, and they get access to a wide variety of articles on all things young Earth creation. Dr. Hartnett, so you're doing a fantastic job, again, on these topics. And so, okay, I think we're basically just going to get into this. Again, I appreciate you being here for this two-part seminar, Dr. Hartnett. To those in the audience, we are making this event interactive for everybody. That includes Sam and I as hosts and you guys in the audience. So we're doing this live, and there is going to be a lot of visuals and just a lot of presentation as we want to keep this thorough. but we are going to be stopping intermittently for questions, discussion, and then right in between both parts, we are going to address your objections, your challenges. So perhaps you hear something said in the presentations that you disagree with. Send in your objections, send in your clarifying questions, whatever it may be. Tag me either at Donny or at Standing for Truth. I'll save those, and I'm sure we'll have a good time engaging with your comments. And so, Dr. Hartnett, if you're good to go.
Yep. Okay.
Okay, let's have some fun. Get your first slide up here that says Earth's magnetic field or Earth's magnetic shield by design.
Yeah.
John?
So, okay. So initially, I want to start out looking at the design features in the Earth's magnetic field. It's a shield by design. And this slide here illustrates this very well. Of course, it's not to scale, but the sun emits enormous amounts of what we call corpuscular mass ejection, CMEs. It's plasma, comprised mostly of protons and electrons. And the Earth's magnetic field acts then as a shield. That's what we call the magnetosphere. You see that sort of shield shape there in the purple around the Earth, deflecting most of those particles away from the Earth. And so the argument here is this is by design. This is part of the creation that God created from the very beginning on the fourth day of creation. The magnetic field of the Earth is something like we are very familiar with in a bar magnet. That's known as a dipole field. On the left here, you see a ring that illustrates a circulating current in the ring, generating a dipole field through the ring with the direction perpendicular to the axis of the ring. And the Earth's magnetic field on the right, with the red magnetic field axis drawn in, and the magnetic field lines coming out from the center of the planet. And you'll notice that the rotation axis is offset from the magnetic field axis. The magnetic field poles, we call them geomagnetic poles. That's the dipole field. So that's like illustrated on the left, that's the magnetic field coming out of the north and south poles. And that's offset currently around about 9 degrees offset from the rotation axis of the Earth. Oops. Sorry about that. Slide 4. However, there are also non-dipole modes. So the dipole mode we saw earlier comprises about 73% of the total energy in the magnetic field. I just checked that before we started today, and that's correct. But also there's higher order components that then would make up about 27% of the energy in the field. What's illustrated here is a quadrupole field, which you could imagine a quadrupole is like having two dipoles opposing each other. So therefore you get two norths and two souths. Not north opposite south like in a dipole, but you see alternating north south around that illustration there, around that grid. And you'll see that the force is always perpendicular to the magnetic field lines. You can build it out of 4 coils. You could do that, combine it, and you could create your own quadrupole. Then there's higher order terms like the octapole. So instead of 2 norths, 2 souths, you'll have double that. You'll have 4 norths, 4 souths. And you can go higher and higher and higher into n pole, n an integer, of spherical harmonic modes. And in modeling of the Earth's magnetic field, called B field, that's the magnetic field, normally 10 high order modes are included in that model. Now, I showed you earlier what we call the geomagnetic north and south poles, but also there's those non-dipole terms, and they mix into the dipole, and so you have what we would then call the magnetic poles, north and south. So we're not calling them geomagnetic now, we're calling them the north and south magnetic poles, and those poles wander around. Currently, you'll see that the north magnetic pole is about 4 degrees away from the true geographic North Pole. And it wanders around because the energy in the non-dipole field also moves around. And so you see on this map here, it's been moving around for quite some time. And people often say, oh, it's moving very fast now. I think recently it's been moving up to about 50 kilometers per year. And so some people say this is sign of a magnetic pole flip. Well, number one, that we need to define terms here. We are not imagining a change in the rotation axis of the Earth. That would require an enormous amount of energy to do that. But what we're talking about here with this wandering around and a potential pole flip is the polarity of the magnetic field, that north could swap to south and vice versa. I don't know if that's going to happen, but we'll talk a little bit more about that later. The south pole, though, this is the south magnetic pole. It's now some 26 degrees away from the geographical south pole, from the rotation axis south pole. That's quite a long way. It's been wandering for many, many years. And you see this very small yellow squares here with the dates in them. Those are actually observed or measured dip poles over the years from 1903 to 2000. A dip pole simply means the point where the magnetic field is vertical to the Earth's surface. And so that really is what defines what we would call the magnetic poles, north and south. So it's wandered quite a long way off being, in the past, being much closer to the rotation axis. So what generates it? Where does the field come from? Well, you have to look into the Earth, into the core of the planet. And if you look past the mantle down into the core, we see two layers. There's the outer core, which is liquid, and the inner core, which is solid. And we're not going into it today, but even the very fact that we have a solid inner core and a liquid outer core under massive pressure is let's say, is a uniformitarian evolutionary problem. I mean, in terms of formation of the planet on evolutionary timescales. But that's another issue. So the source of the field then comes from this liquid outer core, which is under very high pressure. It's actually a liquid of iron and nickel. And the Barnes model, first proposed by Thomas Barnes in 1971, he suggested that the core is rotating, and you get then a current, a circulating current in that liquid. So it's an electrical current circulating in the liquid, and that is essentially a Coriolis effect due to the rotation of the core itself. So like the model mentioned earlier, and here illustrated again on the right, that is a simple dipole field model. So that circulating current that's, say, in that metal ring generates that dipole field. Well, on the left here, under the Barnes model, we have a circulating electric current that generates the Earth's magnetic field, both the dipole and also the non-dipole terms. The non-dipole terms coming from turbulence in that core. These are different types of turbulence that can occur, and so energy can shift from the dipole into the non-dipole terms. But what's very significant is the Barnes model posits that because the conductivity of the metal is not infinite, therefore it's not a superconductor, it has a finite electrical resistance, that energy will be lost over time. This is just a second law of thermodynamics, ohmic decay, resistive loss, whatever way you want to call it, that energy will be lost and converted into heat, and therefore the magnetic field strength, the intensity of the field, or we could say the total energy in the field, should decay, and that energy is lost to heat. And we'll see a lot more of that as we go on. The Humphreys model, built on Thomas Barnes' model, Humphreys suggested, here's a timeline here, he suggested that at creation, we see a decay in the Earth's magnetic field. So we look at the left side graph here, you see a decaying field strength in the magnetic field, and then we get to a point around the time of the flood where we have rapid reversals in polarity. This is not the rotation axis of the Earth, this is the polarity of the magnetic field. Rapid reversals and fluctuations occurring over hundreds of years after Noah's flood, and then we see some further fluctuations, then eventually back into a decay process. And on the right, Humphreys cites certain archaeomagnetic data. This is from sampling of rocks, the magnetic field seen in rocks and their polarities that they exhibit in those rocks. You can look that up and read that article I've listed there from the ICR website. We also see currently in the Earth's magnetic field various anomalies. Now, under the old Earth paradigm, the Earth's magnetic field should be as old as the Earth, and they claim that is about 4.5 billion years. So that if that field was weakening according to the energy lost in the core, in the circulating currents in the core, then how could that be sustained for billions of years? That's the big question. And the geophysicists propose a dynamo that sustains that field. But this here is called the South Atlantic anomaly. This is a region in the South Atlantic where we see a very a weakening of the dipole field. The dipole components of the field are getting very weak. And the evolutionist would argue that the energy is going into the non-dipole modes and eventually will swap back again into the dipole modes. And this is sort of sloshing backwards and forward in this self-regenerating dynamo over billions of years. This is the claim that they would make about this observation. So I decided I'd ask Dr. Humphreys himself what he thought about this. And he said, I've only done the energy calculation accounting for the non-dipole components, which are important, from the year 1900 onwards. And we can say with certainty that the dipole component energy has been decreasing steadily since the 1830s. Very probably the total energy in all components has been decreasing since that time. Now, he says 1830s because that was the time when Carl Friedrich Gauss first made measurements of the magnetic field strength. And Humphreys goes on to say the present decrease in the South Atlantic anomaly is probably due to the decay and perturbation of small loops of current left over from the large disturbances in the flood year, when the field was reversing itself rapidly. So, like, you remember that slide earlier, he talked about rapid reversals during the flood year and after the flood year, and these things would, sort of chaotic turbulence would continue long after that period of time, and that would weaken the dipole components in the dipole field. These are two plots of Humphreys' original data taken from his original paper. On the left is the whole data set that he used over 100 years. The blue is the total energy in the magnetic field. Red is the energy in the dipole field, and green is the energy in the non-dipole. So that's all the other 9 modes, 9 multipole modes summed together in the non-dipole field. So that's what he used. But then he took, for his calculation, only the data from 1970 through to 2000. So he looked at the total energy, that's the blue curve on the right, and from 1970 to 2000. I noticed that the data from 1960 is extremely, how would you say, has a high quality, so that this is an exponential curve fits that line very well. So he could as easily have used the data from 1960, though he said he believed that the data from 1970 was the most accurate data. Now, that may well be the case. And from that analysis, he determined that using this equation on the right for the total energy, he determined that the energy in the total magnetic field decreased, let's say, every 1400 years, it halved. Now, I've fitted this to the data from 1960 to 2000, so I've done the same fit as he did. I used an extra 10 years at the beginning, 1960 to 1970, and I got a number almost the same as his. You see that 1351.4, that's the time constant, or you say the halving time constant. So every 1351 years, that means the energy would go down by a half in the total field. However, you fit the same exponential, this one on the right there, you fit that to the whole data set from 1900, you see that the decrease is it's a longer time constant, takes much longer. Now, I also found, and mathematicians out there will know this, if you expand an exponential where the exponent is very small compared to 1, then it's a linear curve. So this means in this situation, if the time period is short, this is t here in my equation, if that's t is much less than t naught, the time constant, then the equation is a linear function. That means a straight line. And the linear functions fit the data just as well as the R residuals you see on the right here for the bottom set of data, that the linear curve fits that extremely well. And I'll discuss this more later. Now, it is worth noting, though, that in the last 100 years alone, 7% of the total energy has been lost from the Earth's magnetic field. If it continues at this rate, then it won't be very long before the Earth has no magnetic field. It'll be gone. And that is, again, another biblical creation discussion issue that I want to cover in a lot more detail in part 2. For the long-age geophysicist who believes that the Earth is billions of years old, he has to regenerate that magnetic field energy with what they call the dynamo theory. But where is the evidence for the dynamo theory? And I'm going to get onto evidence later. I would argue from what evidence there is that none of it supports a dynamo theory. So it's believed only because of a rejection of the true biblical history as outlined in the Bible. I'm talking about the time scale, the creation events, the details of creation, and the observations that we have currently in the present. Thermodynamics tells us that energy is lost as heat. Every process, and including this one, because of the finite electrical resistance, energy must be lost from the magnetic field, and it dissipates over time, as indicated by Humphreys and Barnes. I call it now the Barnes-Humphreys model. Okay, we're going to come back to that a little bit in a minute, but let's now have a look a bit more detail at the shield, the magnetic shield that the Earth's magnetic field provides as the Earth travels in orbit around the sun. Now, the protons coming from the sun, well, there's electrons as well, some of them get past the Earth's magnetic field. Some of them enter through the north and south poles, and they get trapped inside this region we call the magnetotail. You see that plasma sheet. The radiation, actually it's particles, charged particles, get trapped in there, and you see the pink regions around the Earth. These are called radiation belts. Again, they're really particles. The protons and electrons are trapped in these regions we call the Van Allen radiation belts. These have been illustrated this way. There are now 3 known belts. 2 are shown here. The inner belt is mostly protons, the red inner belt, and the outer belt mostly electrons. The third belt is somewhat transient and quite weak. So this is essentially the shield for the planet against, particularly, against the CME radiation from the sun, but also from the very high energy cosmic rays, which are actually high energy charged particles coming in from the cosmos. And the charged particles from the sun essentially charge up. They charge up by adding protons and electrons to the Van Allen belts. And this has 2 design purposes. One is the obvious one, that it acts as a shield to absorb a lot of the direct particle bombardment on the Earth. And the second one is the shield reduces the impact of much of the high energy cosmic rays. So they still get through, a lot of them get through, but it reduces their impact, which is quite important. And we'll get to that, a bit more on that again in a minute. But what is obviously very pleasant and beautiful to see at the North and South Poles are the Aurora Borealis and Aurora Australis, which is where those charged particles insert themselves past the Van Allen belts and come in through the poles, and they are as they are coming down, they create these auras colliding with atmospheric molecules, and that is it's like God put on a light show. This one here is the Borealis seen at Fairbanks, Alaska. And as part of the design principle, the sun boosts up those Van Allen belts, shielding belts, and shields us from these cosmic rays. But the cosmic rays, or the really cosmic particles, are the source of cloud seeding. So that's like a cloud chamber in a sense. You have high energy particles coming and they form the clouds of nuclei for the water vapor to condense onto, creating a cloud layer. So indirectly, the sun's activity controls the formation of clouds because it moderates the effect and moderates the effect of the sun's radiation on Earth. So we have global cooling or global warming is controlled by this mechanism. So it's a feedback control system. Now, recent work, this is published in 2025, so it's this year. A physicist, Dr. Ned Nikolov, and he has a co-author, he studied the effect of cloud cover controlling Earth temperature. And he discovered that there are two factors. The first one is reasonably obvious, that total solar irradiance, that is the total energy intensity of the energy coming from the sun at the top of the atmosphere, is a primary source of heating. That accounts only for 15% though. And so if the sun's intensity goes up and down, as it does over time, that's a fairly weak contributor to global warming. What is the most important contributor is the reflectivity of the top of the clouds. That's called the albedo. That's reflectivity as seen from space. And white cloud cover is extremely good at reflecting the sun's rays. And that contributes 85% to the amount of radiation getting through to the surface of the Earth, and hence global warming. And you see on the right here, he's modeled it. The pink is his model based on the global temperature anomaly, and the blue is the observed albedo, the top of the cloud albedo from the CEROS satellite data. And he's laid them on top of each other, and you see that's quite a good correlation. Now you see, as a function of time, the albedo is decreasing over time. So if albedo is decreasing, that means reflectivity is decreasing. That means more radiation is getting through the cloud cover, and therefore would cause a systematic heating at the surface of the planet. In fact, it heats the oceans, and the oceans absorb that energy and then re-radiate it. So the ocean sea surface temperature is the next step in that chain. So there's these interrelationships, and this is really important because these interrelationships are part of the design. You see, the outer core of the planet generates, or let's say maintains or sustains circulating currents. Now, they are decreasing, they're losing energy, but they generate the Earth's magnetic shield, and that magnetic shield controls the cloud cover because of the shielding effect of the protons from the sun and the cosmic radiation. It's a feedback control system. However, looking at cosmic rays coming in through the atmosphere, they seed the cloud cover by providing condensation nuclei for clouds, and the clouds then control the sun's radiation through the albedo, the reflectivity, at the top of the clouds, and that then controls the Earth temperature. So you see, these are all interconnected and interrelated. Now, one objection I've run into many times when I've been talking about the Van Allen radiation belt, people have criticized this whole issue that astronauts could never have gone to the moon because they couldn't travel through the Van Allen radiation belts. Of course, there is radiation there, and the Apollo mission astronauts were aware of that. They even wore those badged dosimeters to see if they were getting any significant doses of radiation, and they would report that back to the control system. But the principal danger of the Van Allen belts is high energy protons, which actually are not that difficult to shield against. The metal of the spacecraft was reasonably good at shielding against them. And the Apollo navigators plotted a course through parts of the belts that were the thinnest in terms of that particle density, limiting their exposure. On this website, I've listed it here because this is heavily discussed on the internet. You can go to that website and you can search this. But James Van Allen, reportedly said the recent Fox TV show, which I saw, is disingenuous and entertaining assemblage of nonsense. The claim that radiation exposure during the Apollo missions would have been fatal to the astronauts is only one example of such nonsense. And I'm admitting that this quote is controversial, but I'd like to point out to people that people who were living at ground zero of the Hiroshima and Nagasaki nuclear explosions, these are people who are living within a couple of kilometers of the blast site. They lived on very, very long lives afterwards. And some years ago, it was about 5 years or maybe more than that, maybe 7 years ago, I looked up and I found that for Hiroshima survivors alone, there was still about 400,000 alive at that time, only 7 or 10 years ago. So they would have received massive doses of radiation, far more than the Apollo astronauts would have received passing through the Van Allen belts. So there's something worth considering as well. And another important feature of cosmic rays, and remember the Van Allen belts only inhibit the penetration of cosmic rays into the atmosphere. They don't stop it. Cosmic rays come through and colliding with atmospheric nitrogen-14, normal nitrogen molecules, they convert it into radioactive carbon-14. Carbon-14, of course, has been now, we know, used as a clock, like as an animal or a plant consumes that carbon-14 containing material, and then while they're alive, they continually consume it, and so that carbon is constantly being replaced in their bodies. But when the plant or animal dies, the radioactive clock starts ticking because they're no longer absorbing that level of carbon-14, and then that's how the clock essentially works. You look at the ratio of carbon-14 to carbon-12 in the specimen. But the assumption, the evolutionary assumption, is that when you use the carbon-14 as a dating method, that the carbon-14 in the atmosphere is the same today as it was back in the past. So that's essentially, we could say, is an evolutionary assumption. And that is clearly wrong, because carbon-14 is continuing to build up in the atmosphere. It's been observed, measured, to be accumulating. So a creationist would say the time scale is very short, and we also know, based on the decay of the Earth's magnetic field, that we can get some estimate of what the carbon-14 accumulation rate would have been in the past. So we don't assume it's a constant. And we also have some idea about carbon-12, because during the flood, the global deluge, most of the carbon-bearing plants and animals were buried under kilometers of sediments. So we can make biblical creationist assumptions when we do carbon-14 dating. However, assuming only evolutionary assumptions, if we look at carbon-14 ratios, carbon-14 to carbon-12 ratios for two different minerals. One is diamonds, like this diamond on the left here. If we look at them and measure their carbon-14 to carbon-12 ratio, which has been done, a number of samples were taken by a team at, I believe it was the Institute of Creation Research, and they sent it off to 3 different carbon dating labs, where the diamonds were vaporized, turned into carbon dioxide, and the carbon-14 to carbon-12 ratio was measured. Based on evolutionary assumptions, they returned an age of around about 56,000 years. Now, that's not the 1 billion to 1.5 billion years that a diamond is supposed to be, the age of a diamond. I mean, they're supposed to be formed in deep in the earth under high pressure and temperature, and they come up these flukes, these diamond pipes in volcanoes, or the sides of volcanoes. So that's a big difference from 1 billion years to 56,000 years. And then they also took samples of coal. They got coal from registered coal banks. These are banks where they collect samples of coal from around the earth, and the data about them is all logged and catalogued. And they took these samples, a number of different samples, and divided them up. So they're measuring different samples, but divided amongst about 3 different dating labs. That coal was at least 30 million years old, according to the evolutionary assumption. But from the labs, the dates that were returned were of order 45,000 years. In fact, I would add that all carbon-bearing minerals, whether from organic or non-organic origin, always return carbon-14 dates no older than 45,000 years. 45,000 is common, but maybe with the exception of the diamonds, pretty well all others are less than 45,000 years. So these were all with evolutionary assumption. Now, if you convert that, or let's recalculate those ages based on biblical creation assumptions, like the ones I mentioned earlier, you get dates for the diamond somewhere around 6,000 to 7,000 years, and for the coal somewhere around 4,500 to 5,000 years. That's a far cry from the billions or tens of millions of years. And carbon-14 has been used also to date dinosaur bones. Now, these are not like petrified fossils. These are bones that are still bone, containing bone. They're not been, the calcium has not been replaced with minerals. Some of these bones actually stank as they dug them out of the permafrost, the northern permafrost. And when they thawed out, they smelt because they were like rotting flesh. And also soft tissue has been found that contains carbon-14, and we'll talk about that in a minute. But look at these various samples taken and dated from 1989 through to 2011. And these are all dated with commercial dating labs. And you'll see the dates are all pretty much all less than 32,000 there. So they're in that range with error bars supplied by the labs that are very, very restrictive in their date ranges. Of course, this is with evolutionary assumptions. Certainly, for the dinosaurs, they're nothing like the 65 million years that is claimed that when the dinosaurs died out from some meteor impact or something like that, allegedly. And then there is the very famous discoveries, and there's much more to it than this, but this is the first one that Dr. Mary Schweitzer and team published in Science, a very one of the top science journals, and it was an analysis of T-Rex tissue that was not only soft, it was resilient, flexible. She said that if you stretched it, it would spring back. And they went on to discover red blood cells and even later DNA. Now, how does DNA survive 65 million years? It's quite unfortunate, really, because Dr. Schweitzer has a evolutionary worldview. She couldn't see that this was as simple as that the sample is not that old. It's certainly less than 10,000 years, certainly less than possibly even way less than even 7,000 or 6,000 years, depending on when the flood occurred. Because I believe pretty well all of these dinosaurs were buried during the global deluge. You can't imagine a catastrophe any greater that had the power to rapidly, almost instantly bury alive large animals in a catastrophic process. In fact, that catastrophic process is necessary to even get fossilization to occur, because you must exclude oxygen to prevent bacterial breakdown, which would occur if it was just like rotting carcass in the atmosphere on the surface. So again, this is a testament to a young Earth creation model. The Earth's shielding by the magnetic field is a very important design feature. It tells us that God had a plan, or has a plan, for this planet, but we see that it is decaying. And it has a finite time left in it before all the shielding is lost. Now, if the half-life of the current exponential decay if it is maintained at that 1400 years, that's every 1400 years it halves, then it will be very quickly lost. But as I mentioned, I've also seen that it fits a linear curve. In fact, if you use the linear curve, the decay is even faster. So that process, or let's say the time to lose the magnetic field, is only thousands of years. It's not billions. And so the dynamo theory is only believed because of the rejection of the true biblical history. It's not like there is scientific evidence of a dynamo existing and that they can show that it will regenerate the field. All they have is what we would call forensic science. They're looking at past evidence and they're trying to build their model based on that. No one will ever invent a time machine. To my knowledge, none has ever been invented yet, and none can ever be invented. So no one has any access to the past. It is in principle impossible to travel back into the past. And all dating techniques require unprovable assumptions. So all techniques are applied in the present based on measurements in the present, and there is no past time measurements available. Now that's true also for creationists. So our models also are based on what we observe in the present, and we can build models to explain what we observe, but a biblical creationist model is based on the biblical history being true. Now, this brings us to the end of the first part, and I wanted to point out to you that you could read my new book that basically outlines from a sort of a physics perspective the biblical creation model. It's layman level. I've tried to keep the equations to a minimum, and it really illustrates the Creator's design for this planet Earth. And you can get access to that book, available as a PDF, by signing up as a member, a premium member to my website, for as little as $5. And you can download the PDF of the book, 21 chapters as listed here. So that brings us to the end of the first part.
Dr. Hartnett, again, fascinating information. The decaying magnetic field, C14 where it shouldn't be, diamonds, coal, and dinosaur soft tissue. And these are a few of my favorite lines of evidence as well. We've got a lot of audience engagement, which is what I like to see. And so we'll see what kind of rescue devices and potential responses we can get from those who reject young Earth creation. I've got several of my own questions, especially on C14, but I figured let's go in order. We'll start with the decaying magnetic field and then go from there. Sam, anything you wanted to add first, though, brother?
No, yeah, I want to thank you for your time in that presentation. I also agree that these are fantastic arguments, and so I'm curious to see how you respond to some of the objections from the chat.
Well, I'll tell you why I like these pieces of evidence too, Dr. Hartnett, is because in the creation versus evolution debate, there's a lot of discussion and discourse on what I call agnostic lines of evidence, where you have a piece of evidence that in a way both creation and evolution can account for. I think the most meaningful way to progress in this debate is to provide the best pieces of evidence that are discriminatory evidence, as in only one model can explain or account for the data, or one model simply has the most parsimonious explanation, which I think is the case for the magnetic field decay, C14, and these organic bio material or molecules we find in soft tissue, collagen, so on and so forth. And so I did ask the chat what their favorite counter is to the decaying magnetic field. And so here's a good one where we've got many of the points into one. And so Andrew Cumming, appreciate the interaction here in our live chat. Again, this is a seminar that we want to keep comprehensive, and therefore we enjoy and find it important to engage with our critics. And so Andrew thinks it's wrong, and why? Well, here's a couple reasons. Dr. Hartnett will get you to respond. He says the field strength has not been exponentially decreasing because we've measured it from geologic and archaeological samples before 100 years ago. What's a good way to engage that?
Okay, so let's break it down clearly. From the last 100 years, when we do have absolute direct measurement data, it has been exponentially decaying. But as I pointed out, against a time constant of 1400 years for that last period of the data, or if you take the whole data set, it's about 3,300 years as the time constant. This is the halving time constant. Then an exponential fit, it will fit, but actually it is actually a linear fit in reality, because an exponential curve with a small exponent less than 1 is a linear curve. That's a mathematical fact. So you can just fit a linear curve to the last 100 or 200 years, because we do have data before the 100 years, and it's decreasing. The total energy is decreasing. Now, Andrew mentions earlier measured data from geologic or archaeological samples. These are archaeo-intensity measurements, and they are measurements of the Earth's magnetic moment. And I want to cover that in the next segment, the next part, where I'll look at that data and we'll see. So just getting ahead of myself a little bit, I agree with him that prior to at least 200 years ago, the measurements do not support a exponentially decaying magnetic field. They don't, in terms of the total field strength. But if we can hold off now until we get to the last part of part 2, I'll go into this in a lot of depth. So if Andrew, you can stay online, I will cover this in great detail.
Yeah, let me tease them real quick, and Sam, we'll throw it over to you for a question. Part 2 is a biblical creation model that accounts for this data. It's thorough, that Dr. John Hartnett has put together. And so stay tuned for that. We're not only debunking an old Earth and providing some pieces of evidence for young Earth, we're bringing it all together into a good, solid science-based model. Sam, any follow-up questions, brother?
Yeah, he did ask a follow-up question, and we appreciate Andrew because he does ask good questions. So he asked, how is fitting a preconceived decay curve to one data set a parsimonious model?
Do I interpret it correctly? He means fitting a particular model, so therefore fitting a particular exponential decay curve to it. Of course, that's how we do curve fitting. We propose a model and we fit it to measured data. If it doesn't fit, then the model is rejected. But in this case, Humphrey's halving exponential decay curve, I mean, that exponential decay could be based on any base. He chose to use 2. But since the data set is very small compared to the time constant, he really should have used a linear curve. Linear model is the most parsimonious. It's the simplest. And I will show in part 2 what that leads to if we use a linear curve.
Yeah, because he could I believe he might be asking how this is consistent with our model or inconsistent with their model, which should be obvious.
Yeah. So I think we need to hold this off because once we get into the details later on, it will all become quite obvious.
Yeah. Okay. I appreciate that. Dr. Hartnett, did Dr. Humphreys predict rapid magnetic reversals during the flood? Or can you speak to that a little bit and help us understand what's going on there?
I don't know if you use the word predict. I'm not sure if that's the correct word. But he did his model that he illustrated there, which was not, it wasn't quantitative. It was just qualitative. He expected field reversals based on the idea of a circulating current with turbulence in that current. And so he would say he expected field reversals to occur. Now, they're a measured fact. If you look at rock strata, we see there's certain types of rocks that crystallize on a certain time scale. They lock in the polarity of the magnetic field that they've been subject to. So there's cooling magmas that when they cool, they grab hold of the contemporaneous magnetic field at the time of their cooling. And so you can see them, the evidence is that the field did flip. The argument between a creationist then and an evolutionist is the time scale on which those polarity reversals occurred.
So as a biblical creationist, we do want to have the best arguments, the most consistent and well-balanced model. So when engaging the critics or discussing this issue out in public, we should agree that reversals have taken place, but they took place rapidly during the flood.
Humphreys would say so. He would say during the flood. As you'll see later in part 2, in my model, I'm saying, actually, I believe that it happened over a much longer time period.
Okay.
But no, to be fair, his model is starting in the flood, but still happening post-flood. That would be how Humphreys described it.
Okay. Well, I guess anything further on that point we'll save for part 2. But I guess in a way, we just answered this question here. The analog zone asks, how do you know the magnetic field hasn't fluctuated in the past or will fluctuate / flip poles in the future? But if I'm understanding you correctly, Dr. Hartnett, you are saying that, okay, there is evidence for this, but it happened in a short amount of time rather than a long time scale.
Correct. I am saying that. That's right. And because it has, I do believe it has flipped in the past. And right now we have about 27% of the total energy is in the non-dipole terms, non-dipole modes. A pole flip is possible if this trend continues, where the non-dipole modes are loaded up with more and more of the energy, then it is possible to have a polarity flip. And I keep repeating this because a lot of people seem to misunderstand this. We are not talking about the rotation axis of the Earth. We are talking about the north-south magnetic polarity exchanging north with south, south with north. And the mechanism is like that quadrupole. You saw there was 2 norths and 2 souths. In the octopole, you have 4 norths and 4 souths. So you could see that as you have higher and higher order terms, the field lines become very, very interwoven, very complex. So if you're putting more and more energy into the non-dipole terms, then the field lines are getting twisted up and it becomes very complex. So one could imagine a pole flip to occur.
Would there be any consequences of the poles flipping rapidly versus slowly, gradually?
Yeah, I mean, the magnetic field has a lot of life-relating consequences. very simple ones are like navigation for birds, animals. Bacteria use the Earth's magnetic field to navigate. There are many of these type of consequences in living animals and I don't know about plants, but animals for sure. And also a magnetic field is important for health. We are creatures that live within a magnetic field, and I believe that we are electromagnetic creatures. Now, I don't know the details of a lot of this, but our brain is electromagnetic, and so what would happen with polarity reversals rapidly, I don't know, but one might imagine there would be even effects on the human brain. Now, I'm just speculating here because we are electromagnetic creatures.
Are the other magnetic fields in our solar system and other planets, what we know about them, are they in line with young Earth creationist expectations, Dr. Hartnett?
Yeah, they are actually. And based on another model that Humphreys developed in the 80s, he developed it around this idea that at the creation, God created the Earth's magnetic field from the protons, because the Earth initially was created from water. And as you know, water has a lot of protons in it. And God supernaturally aligned the dipole moments of all those protons. Proton is it's the simplest magnet, you might imagine, the simplest dipole. And by aligning them, you create a uniform magnetic field. He based his model on that idea that all planetary systems in the solar system, their magnetic fields were created on day 4 of creation. The Earth, of course, preceded that because the Earth's material was created on day 1. But based on that model, he then predicted the magnetic field for Mercury would still be within some range. And I can't remember the name of the spacecraft there, but one of the spacecraft, maybe it was called Messenger or something, they actually measured for the first time, this is about 20 more years ago, the magnetic field of the planet Mercury, because the evolutionists expected to be extinct because it's, billions of years old and it's a small planet that doesn't have a liquid core and couldn't sustain a magnetic field. That was the argument. But it does have a magnetic field, and that the magnitude of it was in line with Humphreys' free decay model. And I think Mars might have been another one that came within expectations of his model. The other planets were already known, I think, so that's not really a prediction, but they all come within the parameters of his model based on the biblical creation account.
I can't remember the details fully, but some in the world of young Earth creation that might be reluctant to argue that there were rapid magnetic reversals. I think they've explained some of this data as well. We're not looking at flips. We're just looking at weaker and stronger areas. Are you familiar with that? I'm just wondering what would be a good way to...
I'm not, because the data is around the coercivity of certain minerals, and there's regions like zones within certain minerals that are more or less have a higher or lower coercivity. That means the ability to retain a magnetic field. And they find in certain samples regions that have opposite polarity within the same sample. So I think that's hard to justify that it was just weaker. In other words, it was all in the same direction, but has stronger or greater or lesser extent. I think polarity reversal is quite distinct from that.
Yeah, so we don't really, as creationists, we don't need to fear reversals. And for many reasons, you're going to get into, I think, in your second presentation, how this all comes together and how this works according to your model. So as creationists, we shouldn't be reluctant to agree with that interpretation then, Dr. Hartnett.
No.
Okay, well, let's move on to the C14 one now. And we got several good comments here. I'll ask my own question. So, firstly, I really appreciate what you said on that point. I think that's a really incredible line of evidence for a young Earth. The fact that we find C14 where we shouldn't, if these samples, diamonds being the hardest substance on Earth, essentially resistant to contamination from my understanding, supposedly billions of years old, yet we find detectable levels of C14 in coal too is quite fascinating that we find C14 in coal. So I've heard from more informed critics, Dr. Hartnett, I've heard this specifically too from Dr. Hugh Ross. He and others, they've argued, well, the reason why we find C14 where we shouldn't, let's take diamonds, for example, is because nearby rocks or nuclear material from nearby rocks can essentially work towards recharging those samples deep within the Earth. What would be a good response to that if someone were to use that on you, Dr. Hartnett?
So what is he saying, that some radioactive source nearby a diamond lattice can change the carbon-12 into carbon-14?
I think so. I think that's my understanding.
That's not the actual reaction process. The reaction process in the atmosphere is nitrogen-14 to carbon-14 through collision with a high-energy particle. So you have to change the proton of the nitrogen, one proton, into a well, you have to lose it because you have to convert it to a you convert it to a carbon-14. So it's one less proton in there. So I would imagine then his idea would have to be that you would have to somehow have trapped nitrogen-14 in the diamond lattice to be able to convert that into carbon-14. Now, look, I'm just speculating here. I don't know. I still think, I would think that I find that very hard to believe that such a process could happen. I mean, possibly, but very hard to believe that that's the answer to it.
Yeah, and if I remember correctly, I've read in some of the rate research that if there is any validity to this recharging mechanism, or however they explain it with nearby nuclear material, they would need, I think it was like 15,000 to 20,000 times the nuclear material to adequately recharge. So I guess, in other words, the rate team looked at that and found out it didn't work. So it's a rescue device that, okay, let's have a look. And it was looked at and it was refuted.
But the cosmic rays, they're called cosmic rays, but they're particles, right? They're very high energy particles. So they can make point collisions with atmospheric molecules. An enormous amount of energy can be transferred to change a proton into a neutron, and to change it into a carbon atom, radioactive, but a carbon. It would be hard to understand how you would get that type of energy through the diamond lattice. Maybe if you saw the diamond lattice, what was fractionated with all sorts of crystal defects, like strings of defects through the crystal lattice, then you might believe that's possible. But these diamonds are very high density lattice with very, very few defects. That's what makes them so strong and so remarkable for industrial use, is the low defect density and very high bonds between the carbon centers. You can get vacancies and some impurities, and those impurities change the color of the diamond. You know, in Australia they mine pink diamonds, for example. I think that might be manganese, if I'm not mistaken. So you can get other impurities, but to get radiation in there, a sizable amount of radiation that's like gamma radiation or something like that, then it would cause massive defects to the crystal lattice. It's about the best I can contribute at this point.
That's good. No, that's good. Sam, I saw you were about to say something. Go ahead.
Yeah, we have another objection here that's somewhat common. And so the objection here is that it's the machine background. And so this commenter, he suggests that it's super hard to keep the surface of contamination off of the samples. But if that was true, wouldn't it just follow that these dating methods would be unreliable across the board?
Yes. Now, that's a good point. You brought that up, because this issue to do with dating with carbon-14 only really arose amongst creationist circles because I've forgotten this gentleman's name, but he had spent a lot of time trying to find evidence of blanks. They're called blanks. So if you imagine that you want to do a carbon-14 date on a sample, and you have a very sophisticated mass accelerator spectrometer, which, by the way, the modern particle accelerator mass spectrometers can measure the equivalent carbon-14 to carbon-12 ratio equivalent to 90,000 years old. So they can do point molecule measurements. So anyway, back to the story. So this creationist was looking for samples out in the I suppose geophysics geologist community, where they had samples of carbon-bearing minerals that could be used as a blank to calibrate the accelerator mass spectrometers. And didn't matter where he looked, research papers amongst the community, no such blanks could be found. So that's saying that if you want to eliminate the possibility of contamination, what you would do is you would calibrate your machine just before you do your measurement run. And to calibrate your machine, you have to use something that has no carbon-14 in it. Carbon, but no carbon-14, so that you're measuring noise, just noise. And then you put your sample in and you measure a signal above that noise. Well, as it turned out, the dirty little secret of carbon-14 measurement labs is that no such blanks exist. So this puts to bed that whole argument of contamination. Now, of course, labs go to great trouble to ablate the surface of a material, to boil off layers, to vaporize the diamonds. In the case of diamonds, they vaporize them, turn to carbon dioxide. This is all to try to get the most pure sample from deep within the material, to overcome any potential contamination issues. But I think it is really interesting that the very thing that the industry wants, that is the blanks, don't exist. And so how do you calibrate your machine? Well, the only way you can do it is calibrating against something with a lesser amount of carbon-14. So, yeah, that's a real problem. It's not a creationist problem, actually. It's a evolutionist problem.
Right. Okay, what about, I've heard some say, okay, maybe not instrument contamination, but contamination in the environment.
Well, surely that's the argument that carbon-14 today, building up in the atmosphere, that's the environment, is assumed to be the same as it was when the sample, animal or plant, died. Actually, that's a false assumption. You can't make that assumption. That's the time machine problem. No one has a time machine. Particularly if you see carbon-14, even in the time period that we've been measuring it, carbon-14 has been accumulating in the atmosphere. So to assume it's constant and then to assume that constant in the past, that is also wrong. But earlier, I forgot to mention that no evolutionists would dare date a dinosaur with carbon-14 because even the most generous estimates of the cleanest uncontaminated sample with the best accelerator mass spectrometer, no one would expect to find any carbon-14 older than 200,000 years, for example. You just wouldn't expect it. But as I mentioned earlier, all carbon-bearing samples on Earth contain carbon-14.
Right.
I just need to get some water.
Yes, and you've earned some water, Dr. Hartnett. Go ahead, brother. And so, okay, these have been great answers so far. Contamination, whether it's instrument contamination,
John,
environmental contamination.
your camera is still on, by the way.
Okay. Well, I think it might have just switched to your other. Yeah, there we go. Okay. And so, environmental contamination and also instrument contamination or recharging the C14 in these samples due to nearby nuclear material. We had Dr. Jason Lyle on too, Sam, as you know, and we talked a great deal about this topic of C14, and he did bring up why attempting to, if I remember correctly, his analogy, and maybe you can help me out, it would be like trying to, if you had a big jug of water and it was leaking out just a ton of water, big giant hole, but then you were trying to replace that with just, a little drop of water every once in a while. Well, you're never going to be able to replace it because you've got, too much is escaping compared to how much could replenish it. So that doesn't work. And
you also need a massively significant source of the contamination. And so what would that be? It's interesting. I've read some articles now that we can make diamonds in a laboratory. What they're trying to do is trying to encapsulate nuclear energy and make batteries that would last forever. Because the diamonds that they can make in a laboratory or like the ones that we find in the earth, nothing can leach through them. And so like Dr. John said, when they take these samples, they cut deep into the diamond. And so we know that the samples are good. And so anyway, just the fact that they're trying to encapsulate this nuclear energy inside of a fabricated diamond speaks on how impenetrable the diamond itself actually is.
If I could say this too, and Dr. Hartnett, maybe you're familiar with this. I heard Dr. Russell Humphreys address the contamination argument environmental wise. And he pointed out how convenient it would be. Okay, so somehow modern carbon just, sneaks into all these different fossils and samples all on the earth, all within the earth. We get these consistent ages. I mean, that's kind of far-fetched, isn't it?
Totally.
Yeah.
It's crazy. A couple of years ago, I asked Dr. John Baumgartner this question about has any evidence been found in terms of arguments for contamination in the diamond samples. And that was only a couple of years ago. And he's a little bit up. He's up on the top of this much more than me, and he said he knew of none that supports that argument. So the original arguments that we've made here for the last 15 years at least, they all stand. They all still stand.
Yeah.
Yeah.
And I'm glad you mentioned that, because we did a seminar maybe a couple months back with Dr. John Baumgartner on the catastrophic plate tectonics model, but we had a whole section on C14, and Dr. Baumgartner made a good point that essentially in 2025, what we know about C14 and where we find C14, there's no good reason other than a philosophical reason to deny the data for what it is. And maybe here's the last thing I'll say on it. Andrew Cumming brings up a paper that attempted to address this, the Southern paper. And it's kind of a hyper specific question, but I'll just say this. Dr. Baumgartner, he responded to that in great detail in the Answers in Genesis page. And then he also addressed it in that program. So as far as I've seen, Dr. Hartnett, it seems like it's the same thing with you. Their rescue devices simply haven't worked, brother.
No, they haven't.
Okay, well, let's move to the third major point that you brought up. Dinosaur soft tissue and these biomolecules that we find in fossils supposed to be millions of years old. The collagen, we've done a lot of good talks on how we find collagen as well. And it's interesting too, because the critics will oftentimes make an argument where it sounds like they think the only example we have is Mary Schweitzer's example. But we've had many talks here. Dr. Brian Thomas recently gave a talk here, and he showed that we now have over 140 papers documenting these biomaterials that are like it's becoming more and more commonplace.
That list now. That list I showed you, that was from 89, I think, through to 2011. And there were many different samples of different dinosaurs. It wasn't just one source.
Yeah.
In fact, Mary Schweitzer herself has gone on to continue to discover different samples over the years since her 2007 publication. Just the other day, actually, preparing for today's talk, I thought I'd Google her name and her publications from 2007 on, and there are many, and they all revolve around trying to understand how 65 million year old soft, flexible tissue, blood cells, DNA, all of this can survive to the present. And so she has made, it's reversing the argument and saying the worldview is true. The dinosaurs lived and died 65 million years ago. And the amazing thing is that we have this now. All we have to do is discover how the stuff could survive for so long. When every lab experiment, every piece of information in experimental molecular biology would tell you the opposite, that it can't survive more than 10,000 years, even under the most ideal conditions. It's called thermodynamics. That's the problem. Thermodynamics is possibly the most supported, how would you say, the most rigorous, unrefuted law of physics, because heat, vibration exists when the universe doesn't have any vibration, doesn't have any heat. Nothing will live. Everything is dead. The very fact that we have energy, we have vibration, we have heat, tells us that things fall apart, things break apart, and you need a design system. You need a very smart, intelligent machinery that opposes the second law and decay, that rebuilds and reverses the effects of entropy and increase entropy. And that's what we call a living thing, a living system. They're the only things that can do it. And so, you know, it just boggles the mind that you can believe that.
It's incredible. That's why I like to say, and I've promoted this over the last month or so by saying this seminar is going to prove exactly why it is a great time to be a biblical creationist.
Yeah. Indeed.
Sam, anything you want to add, brother?
Yeah. Regarding all of those papers, you said you recently searched her name and she's published a few papers. And what are they invoking now as a potential mechanism to preserve this tissue or slow the decay down? I'm wondering if they have something that we're maybe not familiar with.
I don't believe they do, because it was like the tone of them was just what I said. It's like the reverse process. More evidence for the fact that the soft tissue, how would you say, why we find it. Not a mechanism of why we find it, but the fact that we find more and more of it. So there must be a mechanism to preserve it. You understand what I'm saying? It's that reverse argument that seems to be being made.
Yeah. It's a primary belief problem. It's a worldview issue. Yeah.
Actually, I think it's even worse than that. I think it's a category problem. There's a field of mathematics called category mathematics. And I think in this case, it's actually the wrong category. That they're actually imposing a new category that doesn't exist. There are no dinosaur material, soft flesh, resilient material that's 65 million years old. It's a category problem. There's no transition from one form to another because it doesn't exist. It's only imagined. You understand what I'm saying?
Yeah, and they're saying now, and I don't know that there's any publications on it anyway, but I have read articles that claim that they're finding it now in trilobites. So if it wasn't bad enough, hold on, it's going to get worse.
That's 400 million years old, according to evolutionary timeline. Yeah.
Well, they've done experiments now, and we just did a show on one of the experiments. And just in a nutshell, I'm not going to get all the technical details right, but they've tested in the most ideal conditions, one would say unrealistic conditions, how long can collagen last? And the best they could come up with, if I remember correctly, Sam, you'd probably remember it, was 500,000 years. And that's the most ideal, again, probably unrealistic conditions. And some people might be thinking, well, 500,000 years, that's a long time. Well, wait a minute. We find collagen and soft tissues in dinosaur fossils that are 65, 100, 200 million years. So no, it's not even close to where they need.
But even any experiment, no lab experiment can actually determine even that collagen can survive 500,000 years, whatever the number was.
Right.
Because you can't make a measurement on the past.
Yeah.
So all you're doing is doing a lab experiment and then extrapolating that back in time. That's all you're doing, right? Or forward in time. You know, you're not sampling it on that time scale. So again, it's a worldview argument. It's assumptions based on assumptions.
Yeah, and they've invoked, you know, we've had some of the critics here in chat talk about iron, and no one's brought up cross linkage, but these things have been discussed. But as you rightfully pointed out, you know, the one that makes the claim, they've got the burden of proof. So, you know, there's a difference between you know, asserting something that might do the trick and showing that it actually can.
Yeah.
Do you agree?
Yeah. Yes. So that comes back to, you know, looking for more samples. The evolutionist looking for more samples where he can say, I've now found a different dinosaur or a different fossil, an older one, with soft tissue, and using that to support the argument that soft tissues survive now 100 million years, 200 million years. But that's just like stamp collecting. That's like the astrophysicist collecting his different types of galaxies. There's no measurement into the past. They're just building up a database and then using that database to argue that it must be true because we've now found other ones that are even older. But it's still not providing any mechanism how any of it could survive when everything falls apart and breaks down and decays. This shows the extent of the belief in the paradigm itself, the evolutionary paradigm. It just shows how strong their faith is. It's a different kind of faith, right? It's not a faith in a creator.
Right.
It's a faith in their own mind, their own belief system, their own God.
We see a lot of circular reasoning and circular based arguments. Well, you know, there must be a way to preserve these soft tissues and collagen, and there must be a way to account for the C14 found where it shouldn't be, because we just know that the earth is billions of years old, right? So they'll never question the bigger picture. And that's right. That's what you see in the conventional literature. They can question maybe specific points on the story, but they can't question the bigger story. That's unquestionable.
That's right.
Okay, well, gentlemen, what I'm going to do is save any other questions that kind of venture into other topics for our second Q&A, as we're now moving into part 2, which I'm excited for. I know the audience is as well, because you've kind of teased at this creation model. So, Dr. Hartnett, you've done an excellent job here answering these questions and challenges. I think we've largely left no stone unturned there, as much as we can. And so why don't we move into part 2?
Yes.
Okay. So, ladies and gentlemen in the audience, that concludes part 1 of this 2-part seminar event that we're doing all in one program here. And so, okay, we're going to shift into another topic, specifically the creation model that Dr. Hartnett is going to present here. So, Dr. Hartnett, if you'd like me to get your slides back up, I can do that.
Yep, go ahead.
All right, here we go.
Okay. Okay, so this is okay, I'm focusing on a creation-based model. And in the past, creationists have often said that all catastrophic changes occurred in the year of Noah's flood. The model I'm going to present here does not. So I've been looking at a biblical creation model where from the beginning of creation, that really the curse, because after the creation is finished, then at some point after that, we see God curse the universe, and so changes in the universe occurred at that point. And God withdrew some of his sustaining power from the universe. Things were not running down, in other words, before the curse. Decay was not happening, and then he withdrew some of that sustaining power, and then all the effects of the second law of thermodynamics really kicked in. And I'm saying that from that time, the changes were set in motion that led to the deluge, led to Noah's flood, and the effects on the magnetic field of the earth from that time. So we're looking at almost a situation you could say that all the events that occurred after the curse were programmed in at the creation by the Lord, as he could see into the future. And there, you may not know of this, some of you may, but there is data on the anomalous rotation axis, or changes in the rotation axis of our planet Earth, and they're connected to changes in the spin axis of the core of the planet. That's where I explain the magnetic field coming from, and that is connected to those circulating currents in the core and disturbances in the magnetic field, including pole flips. These are all set in motion after the curse and not at the flood. So there's a difference here that I'm proposing from the Humphreys model. Now, I want to start here with the obliquity of the ecliptic. This simply, in other words, is the tilt of the Earth's rotation axis with respect to the plane we call the ecliptic plane. This is the plane where all the planets travel around the sun. It's called the ecliptic because it's the direction, it's the plane in which we see the eclipses, both the solar and lunar eclipses. Now, that axis is tilted currently by 23.44 degrees or something to the ecliptic, or to the normal to the ecliptic. It's the same angle, depends on how you look at it. And the Earth then travels around the sun in its annual cycle, and then the sun travels around the galaxy, or is traveling around the galaxy as the sun circles, sorry, the Earth travels around it. Now, I haven't missed a slide, have I? No. Starting possibly more than 100 years ago, various people were looking at this tilt of the Earth's axis. And there was a guy called Newcomb, John Newcomb, I think it was, who first started to catalogue the tilt of the axis that was being used in astronomy up till, I think, around the late 1800s, if I'm not mistaken. But this has now been the observation and calculation of the tilt of the Earth's axis has been, since 1984, has been collated and computer generated by modern computing techniques. 84 was the DE200 series, probably a mainframe computer back then. And they back then analyzed the observed data between 1911 and 1979 and calculated the change in tilt as a function of time. You see the first curve there, it's a polynomial, a third order polynomial. That's this red curve on the right. I've called it Newcomb 3. The curve is named after Newcomb, even though obviously he's no longer involved, as a sort of a reference back to him who started this idea of calculating these. They're called ephemeroids. That's the position and time of the planets, and obviously the Earth, the Moon, and so on, where they are. And by calculating the effects primarily of the Moon and the Sun, its gravitational pull on the Earth, you can calculate a model for the tilt of the Earth's axis. And that's what this first model is here, the first one generated by computer in 1984. The generation of these things, of course, is a major problem because it's an n-body problem. It's primarily the Moon and the Sun, but it involves all the planets and other bodies in the solar system. They all have a perturbation on the tilt of the Earth's axis. And so they are, this really is a uniformitarian problem if you're looking back in time, because it's not like once you know it today that you can predict what it was back 1,000 years. That's not that simple. And so the models have been developed, and now this current model I'm showing here is a fifth order polynomial that they produced. The ephemerides have been produced and published in the Astronomical Almanac for 2010. I think now that has been taken beyond that. I think they've got up to about a 10th order polynomial. But in the modeling I want to show you, I've used the 5th order polynomial. It's called Newcomb, and you can see it's the blue curve on the right. And you can see it's slightly different to the red curve. And the blue box is my area, or let's say the time zone of interest, the years in the past and into the future of interest. And I've chosen to use Newcomb's 5th order polynomial to model the tilt or the obliquity of the ecliptic. That's as the Earth travels through space. And this is a bit of an illustration of it. You see the Earth is tilted. That's the angle there. That epsilon is the angle, the tilt from the ecliptic. The ecliptic is that plane which the Earth is rotating around. It's where all the planets are rotating around, except maybe Pluto. And it's also precessing. So the Earth is like a top, a spinning top. And as it spins from west to east, it precesses in the opposite direction, retrograde. And that precession would take 26,000 years to travel a full circle. That's the precessional circle. To travel through 360 degrees and come back to where it started, that would take roughly 26,000 years. And then there's another small wobble on the axis as it's precessing around. It's also sort of wobbling around, a very small wobble, very tiny amount actually. And that's called nutation. And nutation is in the opposite direction to the precessional direction. Yeah, oh no, sorry. It's in the same direction as precessional, but opposite to the rotation direction of the planet. So I mentioned that determining the past obliquity or tilt is historical or forensic science unless you have measured data in the past, because you're trying to construct a model of the orbit of the Earth over this 26,000 year period when you don't have data you only have data for the last 100 years or 200 years at the most, a few hundred years. However, okay, before I get to that, a bit more on my creation model. So I've developed this idea that I call it a toy model. So a toy model is just to illustrate some of the ideas of what the model contains and to see if we can express some physics to explain processes going on. And the model is, I suggest that the change in the obliquity of the ecliptic may have resulted from the initial state of the creation of the planet and its core. And primarily, as I said earlier, set in motion after the curse. So, but it starts right from the creation process. On day 2 of creation, God said he separated the waters above from the waters below. And up to that point in time, there was only a ball of water, which was called the earth, from which later the waters below, the waters above, God formed the planet, the dry land, the oceans, and then populated it with all plants and animals and humans. But as part of that waters above process, my model includes icy rings that later, I believe, a lot of it became the Kuiper belt out beyond Neptune, large icy bodies, not just water ice, but other forms of icy bodies, methane, volatiles, ammonia, and so on. But what if part of that process, it left the Earth with a ring of ice, something like Saturn's rings? I tried to illustrate it here. It has, of course, the moon is not shown there, but the moon is also in orbit, as well as some kind of disk of ice as part of that creation process. And I want to model that. That's a part of my modeling task for this toy model, but I'm just giving you the basis of what this model at this stage contains, but I haven't yet developed all the physics for it. So obviously this is on the right is a picture on day 4 of creation, because the sun is in existence. The moon is not seen, but it's there. And this is one of the starting points of the model. There's another aspect to the model. So there's 2 different aspects of it here. On day 1, we see that the Earth's magnetic field would have come about if God aligned all the spins of the protons. This is originally Humphrey's idea. And so you would get a rotating planet with a magnetic field from the aligned spins of all that water, the protons in all the water. And today we see on the right here an illustration of the Earth's magnetic field that we've covered a little bit in the previous session. You see the spin axis of the planet is the green one labeled A. That's the rotation axis. And we have the core, the inner core, and the outer core. And that is separated by the blue B axis, which is the axis of the magnetic field, which in this model is the same as the Barnes-Humphreys model, is generated by the circulating currents in the outer core. But then there's the C here, C1 and C2 are what we saw in the previous session also. That is the measured magnetic north and magnetic south poles, which are slightly different to the polar geomagnetic axis, which is in this model, it's aligned with the dipole field is aligned with the rotation axis of the core. So the core, the rotating outer core, it's the whole core is rotating, but it's the outer core that has those currents that generates the dipole field that we call the geomagnetic axis, or the geomagnetic poles. So they're the 2 elements in my toy model, and I want to show you my investigation into these so far. But before I get into the detail of that, I, you might say, resurrected some of this data by George Dodwell. He was a South Australian government astronomer who died in 1965. So all his data was gathered before 1965. I think 63 might have been the last data point he gathered. He gathered 110 historical measurements from various sources. And this is a bit of an example of some of those sources: ancient Chinese and Egyptian and Eratosthenes, the Greek, you could say early astronomer. Many of these measurements were quite ancient measurements. They are fairly controversial, I won't deny that. And there are even some creationists who don't consider that they have any value. Now, I want to show you something soon that may change your opinion if you think that. I've kept all the data except one, the one that I've put an orange line through, orange background here, and that seems to be a major outlier. And even the comment by Dodwell was that it was possibly from the wrong date. So that's been excluded. But all the other data are used, except I've also added one datum for 2000 AD. Now, to that data, I wanted to try to fit different models. Now, these are all within my toy model. I'm experimenting with different models. This might look a bit strange to you, but the way I'm doing this is I'm looking at the Newcomb formula. Well, I'm using the fifth order polynomial Newcomb formula for what we might call something like the natural change in the tilt of the Earth's axis from the moon, the sun, and the moon and the sun, and the rest of the bodies in the solar system. And then I'm adding to it an anomalous term, an anomalous effect from the observations of Dodwell. So the first model is model number 1. And these curves are all known as Lorentzians. The form is a Lorentzian form. The first one I tried is model number 1. And when I first tried this to fit to the data, I thought, if this doesn't fit, and I tried a Gaussian as well, and if I couldn't simply find something that would fit that data very easily, I would have just given up and decided, yeah, the data's no good. But I tried the Gaussian, as I mentioned, and the fit was terrible. But then I tried this Lorentzian. Now, I know the Lorentzian from my work in electromagnetism. I built ultra-stable microwave clocks, and a Lorentzian will describe a resonant condition in a resonant system, like a resonant cavity. And so the first two lines here, model 1 and model 2, are based around such a resonant system. It's used in other statistical analyses. It's used in mechanical systems besides electromagnetic systems. So I thought I would look at a Lorentzian curve on a time base. So this is a time base here. I'll explain more of this as we go, but the additional letter B is just added as a extra term in a curve fit to see if it improves the fit, but the parameter B should be 0 in the model in terms of what the model should be as we add it to the Newcomb formula. And the second one, the model 2, is actually related to the first one. It's like the real and imaginary parts of electromagnetic resonance. So I thought I would experiment with that as well. And then number 3, I tried later. And number 3 is actually the derivative of number 1. If you take the time derivative of number 1, you get number 3. And I thought I would try that as well. And you'll see from the following what I got. The first one, the red points are all Dodwell data. So you see the Dodwell data, it's hugging the line, very dense because of the very, very small variation when you get up here, and it fits the Newcomb formula very well in the last 300 years. But then where it's controversial is these past data points, data measurements. So number 2 curve, the dash curve there, is the fit to model 1. Model 1 plus Newcomb. And so without the model, it would only be curve 1, which would just be the Newcomb formula. And you see the Dodwell data would departs very strongly away from that. And when you do regression curve fit analysis, you see my B parameter is close to 0. It should actually be 0 because we're adding one model to the Newcomb formula. So there should be no extra term. And you see that the gamma function is called that's the line width. That's the width, the full width half maximum of this line. So halfway up, it should be the width of that line in years. And the T sub R is the resonance time. That's where the peak occurs in this resonance. And that is in the year 2991 plus or minus 368 years BC. So the time scale of this is 0 in the year AD BC and negative backwards and then positive forwards from the year 0 AD BC. That's the time scale. Now, the curve fit analysis is very good. Using residual R, not R squared, but R, you get 0.996. A perfect fit to the data would be R equal to 1. And the chi-squared, for those who understand what this is, chi-squared is also very small, which it should be. Chi-squared should be 0 for a perfect fit, and that's per degree of freedom. That's how many fit parameters we have. So we have, it's n minus 1, 3 degrees of freedom. And so you see curve 1 fits very, very well. So what this is then saying that during the period of time from about minus 6,000 to minus, I don't know, 1,000 or so, you have a very large departure of roughly more than 2 degrees from the Newcomb, expected Newcomb behavior, the change in tilt that would have been expected just from the effects of the sun and the moon. And you see that is more than 2 degrees movement away from that. Then I tried my model 3. I'll come back to model 2 later. Model 3 is a bit different. And you see that the data fit is also just as good. In fact, from the residual R, the data fit is actually better, and the chi-squared is improved also. So it's a better data fit. And the B parameter is closer to 0, as it should be. Should be 0. I like it to be 0. Unfortunately, it's not yet. And the resonance line now almost coincides with the crossing of the expected curve from the Newcomb formula. And so that date now is 3153 or 54 plus or minus 191 years BC. So that gives us a date of some major catastrophic process as the Earth's tilt on the Earth's axis rapidly changed across that period of time. Total change is about 3 degrees. So 1.5 degrees down one way and 1.5 degrees back up the other way, and then recovery back to the expected trend line from the Newcomb formula. Okay, so this is an improved fit. Model 3 is improvement over Model 1. And this has other features, that the change in tilt of the axis decreases as a function of time, decreases, and then increases rapidly, and then decreases back down to the 23.44 degrees that we have today. So what does all this mean? something in the past introduced a change to the Earth's tilt, the obliquity of the ecliptic. Now, the model, in this toy model I'm investigating, I'm trying to find what caused that change in tilt. Now, which model is the better fit? Well, I've already indicated that Model 3 fits the curve better than Model 1, and these are what are known as residuals. So you take the data from the curve fit, and the data for a very good fit should be randomly distributed around 0. So the mean, the median should be 0. And you'll see here that Model 3, the mean and median are closer to 0 than in Model 1. And you see the data is more evenly distributed around 0. There is one feature you might notice which relies only on the last few hundred years of data, which you might say is a period where the observations are more accurate. And you see there seems to be a small systematic trend in the residuals. That is a concern for me, and that is something that needs investigation, and for to strengthen the model, that would need to be explained. Oh, so this model, Model 3, gives in greatly improved value for this resonance or reaction time. And if this is the year of Noah's flood, so I'm not saying exactly it is, but if this is predicting the year of Noah's flood, then it's in the year 3154 plus or minus 191 BC. That's when that occurred. The Model 1 fit to the same data yield a wider range for this, 291 plus or minus 368. So 2,991 plus or minus 368 BC. So the error bars are larger, but it does include that date. The Model 3 result, though, strongly excludes Bishop Ussher's date for the flood in the year 2348 BC. So Ussher's date is excluded, but okay, so Ussher based his date on the Hebrew Masoretic text and the genealogies in Genesis 5 and 11. And he arrived at his date just based on there being, from those genealogies, 1,656 years after the flood, after creation, which was in the year 4004 BC. So he arrived at the year of the flood being that 1,656 years after creation, essentially. But the Septuagint, this is the Old Testament translated from Hebrew into Greek, that adds about 1,500 years to the creation timeline. And according to Henry B. Smith, he published this in 2018 at the International Conference on Creation, his paper, he has a flood date of 3298 BC. Well, that lands very nicely within those error bounds on my 3154 plus or minus 191 BC. So the Model 3 is consistent with a flood year of the Septuagint, if you take the Septuagint as the correct historical timeline. Now, I want to look at the connection of this tilt and the Earth's spin axis to its magnetic field. And to do that, we have a look at measured historical data of the magnetic moment of the Earth's magnetic dipole. Now, the magnetic moment is not, it's a vector that has a magnitude and a direction. So it's essentially telling us the direction of the magnetic field in a sample and gives us a measure of its direction. It can be represented by this circulating current, this picture here, and the enclosed area of that current. So that's like the Earth's core, circulating current in the core enclosing a certain area. And the energy in the field is related by the square. So the magnetic moment is proportional to the B field, and the energy in that is related to the square of the B field. So there's a relationship between the two. So my thinking at this stage is if the spin axis of the outer core moves, it could affect the circulating current in the liquid iron nickel conductor, that is in the outer core, and that affects the magnetic moment of the Earth's dipole. So we want to have a look at historical measurements of the Earth's magnetic dipole. Quite obviously, if the core is spinning and it's a liquid, you will get things like Coriolis effects, and that will create circulating currents. This is quite obvious, and this is used by the Barnes-Humphreys model, and also it's used by the evolutionary dynamo theory models, if there are any. But what we do have is measurements of the virtual axial dipole moment. And these are assembled and collated from many measurements, looking at the axial component of the Earth magnetic moment, and the dates for when these are archaeo intensity measurements. So these are, I say this is a uniformitarian timescale because of the dates are based on uniformitarian measurements of these mineral samples. So I haven't corrected for any of this at this stage. I'm just using this from published data, and this is fairly recent published data, and you'll see it goes back 10,000 years before, BC. Now, if we use the current geomagnetic dipole axis as a proxy for the outer core spin axis and its current offset, this is the inclination of that axis. So if we're saying, if we're looking at the dipole, magnetic dipole field, because we can calculate where that is on the Earth, and that's a proxy for the rotation or the spin axis of the core itself. That is currently inclined to the polar, that's the polar axis, the rotation axis of the planet, by 9.21 degrees. So as the Earth ecliptic axis spins, and the ecliptic changes, I'm suggesting then the core, the spin axis of the core, will also change. That's part of the model. But using model 2, this is so far still just a toy model, playing around with this. By modeling with model 2, if we use this as a proxy for the spin axis of the planet, then it shows a variation back in time for the change in the core inclination
spin axis of the core with respect to the Earth rotational axis. So that seems to change, according to that model, quite rapidly. And so using model 2, I fit to the measured data from the virtual axial dipole moment. These are heavily averaged over many samples, and the error bars are very large. Model 2 seems to qualitatively fit it quite well, and it is also a reasonable quantitative fit with a residual R of 0.744. But I have no mechanism. I don't know. I have no mechanism for this model to fit the core spin axis to a change in the magnetic dipole moment. I'm just empirically trying it as a model. I don't have any underlying mechanism for this to be the case. But it gave me the idea that there may be a logical reason for this, because it seems to fit or have certainly the very general behavior quite well. And so, okay, before we move on to that, as we already discussed earlier in part 1, the control of the cloud cover by the Earth's magnetic field, maybe you could say indirectly through controlling the plasma radiation, the protons coming into the sun and the Van Allen belt and creating that shield, and that controlling the cloud formation, and then that controlling global warming, then one would think that maybe through that long connection there might be a connection to the change in tilt of the Earth's axis, because the general secular model uses the long-term changing tilt over that 26,000 year precessional cycle as their main proxy for the change in the Earth temperature over millions of years. This is very long-term, long-age timescales that they use this for, with a cyclical precessional cycle of 26,000 years. And so that would affect the Earth's temperature also over that timescale. Well, over the measured timescale of the Dodwell data, this creation model fits those Greenland ice core temperature proxy data much better than the Dodwell data does. And it was the then the Newcomb data, number 1, curve 1. So correction there. The Dodwell data are the red dots. That's my curve 2. That fits the green data, which is the Greenland ice core proxy temperature data over this time scale. And the curve 1 is the Newcomb formula from the slow change in the Earth's tilt due to the moon and the sun, is a poorer fit to the change in temperature from the Greenland ice core proxy temperatures. Now look, the ice core proxies are a proxy. They're not a direct measurement of temperature. And so even the time scale here used for the ice core proxies may be wrong, may need to be contracted or expanded, because it's not a direct measurement in the past of the time scale. So there's modeling and there's a number of uniformitarian assumptions made. Nevertheless, it's still an interesting fact that this has a better correlation to this data than the standard Newcomb formula. So here's the basis of my model now. This is the only equations you get to see. If you can imagine here the planet Earth, with the mantle on the right side here. And the mantle is spinning, so that's spinning at the speed of the Earth. That's what we measure against the stars. And inside that is the outer core and the inner core. And the core is also spinning at the same speed as the mantle. Therefore, they're all spinning at the same speed, the same rotation speed, the same rotation time. But angular momentum is a vector. And so the Earth is pointing, the Earth polar spin axis is pointing in the direction of 23.44 degrees from the ecliptic, right? That's that angle there from the ecliptic. And the outer core, or the whole core, in fact, spin axis is also rotating, but it is offset from the Earth's rotation axis by this angle theta. This is called the core inclination angle, and that is spinning. Because of conservation of angular momentum, which is a vector, the directions here are very important. And we can solve this system of equations because we have also the rotational energy here. And I've equated the rotation speeds, this omega, this is the rotation period, well, it's the frequency of rotation of each of the Earth, the mantle, and the core. They're all equal. And we can solve these equations and come up with the change in the theta here, the change in the inclination of the core when the Earth tilt changes. So because the whole system must maintain constant angular momentum, when the Earth axis changes, then the core also must change to counteract the change. That's how a gyro system works, actually. It's a gyroscopic system. And when we have a look at the result of the model, up the top is the curve you saw before with model 3. Curve number 1 is the model 3 fitted to the Dodwell data. And curve number 2 is the Newcomb formula for the Earth's tilt as it's traveling through space, right? The obliquity of the ecliptic. The curve 3 now is how the core, the tilt of the core must change. This is the theta, the inclination of the core with respect to the rotation axis of the Earth, how that must change when the Earth tilt changes. And so you see the Earth tilt changes by a total of 3 degrees, something like that, 3.2 degrees. And the core must change by nearly 30 degrees, which is about a factor of 9 times the amount, much larger change in tilt in the core. And the curve number 4 is what it would have been if it was just the Earth tilt changing only by the slow change according to the Newcomb formula. So the core inclination changes the obliquity of the Earth's spin axis, and the obliquity of the Earth's spin axis changes the core inclination. Either way, it works either way, whichever causes the other. So which is the first cause here? And that is part of the model to try to understand what the cause is. I still need to model the planetary disk idea, but I suspect that that is not the cause of this change in tilt, because I haven't yet done the work, but I don't think it's strong enough to cause this. And the mechanism, it's disappeared from the screen here, The mechanism, therefore, I believe, is from the initial creation event post-curse, after the curse. So if you're looking at the plot here, the green curve, you see at it's minus 7,500 before Christ is the creation or the curse. And the Earth's core, it starts to change. The tilt of the core or the inclination changes quite a lot, 15 degrees or 14 degrees or something, and then changes back and up another, nearly 30 degrees, and then comes back down towards the general trend line or the secular trend line determined from Newcomb's formula. So the cataclysm of Noah's flood occurs somewhere around the point where the green line crosses the is it a black line number 4 for the general trend from Newcomb's formula. You see Christ is there around 0 AD BC, and then finally we get up to 2000 AD, the current time. And that brings us back to that 9.21 degrees inclination from the rotation axis. So all that is basic physics, conservation of angular momentum and conservation of rotational energy. So next step, to see if that change in the core axis fits the dipole moment data from the archeointensity measurements. And within the very large error bars, it's again qualitative fit, general trends. Error bars are large, but it doesn't fit so well after 2000 BC roughly. In fact, it's quite poor once you get above there. So, but that's what the model predicts. Now, the model now has a mechanism. The mechanism is in the core. The rotation of the core, spin axis of the core, causes those circulating currents in the metallic conductor of the core, the liquid, and that causes changes in the magnetic field. The time axis here is still the uniformitarian time axis. I haven't made any corrections for past uniformitarian time. Not yet, anyway. So this is the Barnes-Humphreys model, where we have that circulating current because the Earth's core is rotating. This is like a Coriolis effect. It's very similar in some ways to the circulating wind patterns on the surface of the Earth above and below the equator due to the rotation of the planet. Conservation of angular momentum. In this case, similar processes occur. So Humphreys used published data to calculate the energy in the dipole and non-dipole modes of the magnetic field. Over 100 years, that is 1900 to 2000, he achieved exponential fit. Well, actually, he chose 1970 to 2000 and yielded an energy halving every 1400 years with an exponential fit. I find that linear fits do just as well, with linear residual fits, regression fits, are greater than 0.99 in most cases. So I'm still using the core elements of the Barnes-Humphreys model, but I don't require or don't need to use an exponential fit outside of that very narrow time scale, because it's too short a period to really model the effects of the magnetic field, both past and future. and you'll see a linear fit is better. So this is again Humphrey's model. I showed you these before. Over this time scale, exponential fits do work, but so do linear fits. And these are exponentials, but you can't actually separate the exponential from a linear fit. They're pretty much the same because of the exponent of the exponential is very small compared to a 1. The time compared to the time constant, if you like, is a very small number over this time period. So the next step was to look at the magnetic moment. These are the same magnetic moment measurements I showed you before. And I've added the year of Noah's flood based on the resonance or the reaction time from the model with the was that sort of a light brown area as the region of the error bars. So the flood occurred within that region. And I've also converted Humphrey's data, from the previous one, the Humphrey's data, that's here, the total energy, no, the dipole energy, not the total energy, the dipole energy from Humphrey's calculations, he did those calculations. I've put it on this curve here. So that's the red dots, the few little red dots there. It's only 100 years. And that fits into the dipole. So I've calculated from his energy what the dipole moment would be, and I put it on the same curve. So you see that trend, and it seems to be lining up with the last 1,000 years of the dipole moment measurements. Of course, the error bars are very large. Humphrey's energies, I put all 3 energies on here. I don't have to convert them to anything because he calculated it in petajoules of energy. And I've added the dipole moment measurements from the left side here, and I've converted them into energies using an energy calculation from the B field, converted it into total energy in the dipole field, in the axial dipole field. And so this is the same data really, but represented in 2 different ways. However, we can also see the total energy and the non-dipole energy on this graph on the right. And you see the trend there in the last 1,000 years seems to fit a linear curve quite well. On the time axis is still uniformitarian time scale. I have made no changes or corrections to that. So now talking about the history then, now we're looking back into the past, and of course, that's got its problems as we've mentioned, but I'm using a biblical creation model here, and the time of creation is less than 8,000 years before present. Based on the Septuagint, it's roughly about 7,500 for the date of creation. And using the virtual axial dipole moment data, measured data, converting it to energies, we get dipole and non-dipole terms. And I'll show you how I get the non-dipole in a minute. I assume only standard physics. We can make predictions with the understanding that extrapolation is precarious beyond the data. It always is. But that's what everyone else is doing. I mean, projecting back into the past and into the future. And thus, what follows is only a sketch, because some extrapolation there's extrapolation here. It's busy, so I'll try and explain every part of it, and we'll go through it. Now, there's no error bars on here because it just make it too confusing. But the black dashed curve, which is curve number 1, is the same energy data on the previous slide with Humphrey's data up here in the black. That's up there in the black. I've changed colors here, so sorry about that. So the Humphreys data matched into the energy converted from the dipole data is curve number 1. And we also know that the total energy is the sum of the dipole and the non-dipole terms, with one provision, that as the energy is lost from the core, heat will be generated. So I've made the reasonable assumption that the total energy in the system can't be any less than what's in the dipole. Quite obviously, that's the case. It can't be less than what's in the dipole, because that's energy in the system. And so the light green dots, curve number 3, is the total energy of the dipole and non-dipole terms. And that's decaying. You see the green dots are decaying as a function of time, and then they come down much faster in the last 1,000 years. Well, I've added in another term for heat. As heat is generated in the core, then the heat plus the dipole and non-dipole terms must add up to be constant energy in the system, because conservation of energy, there's no other energy. You've only got the rotational energy. This is only in the rotational system. I'm not talking about heat in the mantle or in the core from the creation. I'm only talking about heat generated by the loss in the core as the field decays. And so those 3 terms should add up, and they should equal the total amount of energy, which is number 5. And they do. This all sums together. This is consistent. So what this is then saying is that at creation, you see the dashed line here, which is number 6. The brown dashed line is the change in tilt of the core of the spin axis. And as that occurs, there are large changes in the dipole energy and the non-dipole energy. In fact, in minus 4,000, you see minus 4,000 there, there's more energy in the non-dipole terms than in the dipole. So in this period of time, which is thousands of years, you see a change in the core spin axis, and you see big changes in the dipole and non-dipole terms. And this is where I believe you have pole flips, where you have large non-dipole components, particularly minus 4,000 to minus 2,500. You have large components in the dipole modes, large energy in the dipole modes, and pole flips occurring. So towards later, after what is it about after 0 AD BC anyway, you see the heat is starting to be generated much more as energy is shifted more into the dipole field and a lot less coming out of the non-dipole components. And then now in recent times, that's all changed. We see the total energy decreasing as we see heat increasing and the non-dipole energy increasing. We see that in the last 1,000 years. These are consistent with the measured energy in the dipole from archaeointensity measurements. So this whole model is based around that and Humphreys measurements in the last 100 years. So the last thing we can do is extrapolate this. And I don't like to extrapolate too far because of the danger of extrapolation. But the total energy, which is the green curve, number 3, is decreasing. The dipole is decreasing quite strongly. And we can say that in the year 2179, the dipole and the heat energy will be equal. There will be as much energy generated from the heat of the decaying field, magnetic field, as is still in the dipole. In 2414, the two components will be equal again. They'll be roughly 29% each. The rest is in heat. And that is roughly what was happening back prior to the year zero, in this pink rectangle. You see roughly the dipole and non-dipole field components are swapping. The amount of energy, this is all in energy terms, and it's going backwards and forwards. And I believe this is where we have massive turbulence in the core. And this was all set in motion from the creation, really from the curse. After the curse, God withdrew his withholding power, and you have thousands of years of turbulence in the core, changing the magnetic field components. And the way this worked was the rotation axis of the core was the mechanism driving these changes in the liquid outer core currents. So that was happening then, and that's consistent with past pole flips, polarity flips, that is, not poles, not rotation poles, but magnetic reversals. And then if we look forward, again looking forward, you see in the year 2414, we've already mentioned this, they're equal. The dipole is decreasing, and the non-dipole terms, as is all the other monopole terms, not monopole, n-pole terms, all the other higher order terms, the energy is increasing. And then by the year 3227, if that trend continued, and that's a linear trend, there would be no energy in the Earth dipole, the magnetic dipole. That means the geomagnetic north and south pole would disappear by that time. That's if the trend continued. But one point is, it really does indicate it's a linear trend. Exponential will actually take longer to head to zero than this would. So that gives you one other point. Within this rectangle, I've scaled the dates. I've tried to correct the uniformitarian dates by scaling dates less than 1250 BC by 26% less, scaled down. Possibly I need to scale the whole data set by that amount. I haven't tried that yet, but that was to bring the first measured data point in line with minus 7,500 or BC, 7,500 BC. Sorry, not BC, before present. Sorry. 7,500 before present, not BC. So the whole timeline is 7,500. I hope I said that right previously. Okay, still work to be done. I need to refine Model 3 fit to address the systematics I showed you in that data, in the residual data. I want to model the effect of the planetary icy disk around Earth inclined to the ecliptic, which I haven't done yet. It's a big job. Develop a model connecting the change in the core inclination to currents in the outer core, and hence the magnetic field. That is to look at the turbulence, to look at the Coriolis type effects in the core that involves liquid dynamics. Yeah, also non-trivial task. So that's the end of the second part. And this is my book again that gives you the basis of this model of creation. Not the whole book, but the book itself tries to build a picture of how God created the Earth, the solar system, the whole system, as part of his ultimate design for life on Earth. And I hope I got things right there. If you want to get a copy of this book, you can simply go to my website. You can search Physics of Creation. There's a page there right now on the front page where this page appears. You can click on that. You will have to sign up as a premium. It costs you as little as $5, and you can download the book. Thank you very much. And I hope there may be a few places where I said 7,500 BC when actually I meant, because minus 5,500 is 7,500 before present BP. I may have got BP and BC mixed up. Sorry about that.
And if I understood correctly, Dr. Hartnett, that is, and correct me if I'm wrong, that is building a model based on the Septuagint dates rather than the Masoretic text?
Yes, correct. Well, it's the other way around. I built the model, found the curve fit analysis, gave a reaction time. I called it a reaction time or a resonance time that is only consistent with the Septuagint date. It's not consistent at all with Usher's date. It excludes Usher's date.
It excludes Usher's date, and it's
Yeah.
only consistent with the Septuagint date.
Yeah.
And the linear way of doing things and all the math, and I'm gonna have to watch that a few times. Dr. Hartnett, that was good. That was technical, definitely a sophisticated model. That all lines up nicely with roughly 7,500 years.
Yeah. So I made in the last slide, I made a timeline correction. I corrected secular dates to align the first date of the magnetic moment measurement with the creation date, because secular dates are based on uniformitarian assumptions. You know, it's the same old problem of measuring the past. And no doubt the measurement of the dipole moments was correct, but dating the samples that were used is the problem. And so you see large error bars even on the dates. The error bars around the dates are plus or minus 500 years. And the error bars on the moments are even much larger than that. Though they've used many samples, averaging many samples, I didn't go into all these details. But on the website, you will find my blog post as I develop the model. There's about 6 articles now, and there's a lot more detail as I developed it. But you have to follow the mind of the scientist as he's developing a model. But I try to explain everything as I went. And I also explain the limitations of where I've gotten to so far. In fact, that last slide at the end of the 3 things I still need to work on.
And it's about model building. And so
Yes.
that's really good. There's some good feedback in the chat. There was a geophysicist in our audience earlier, and I'm trying to, the comments were flying by pretty quickly, but he had an objection with the linear calculations, and I can't seem to find it, but you supported your methodology, if I understood correctly, with your second presentation, because he had put forth that objection during your first talk.
Yeah, anyway, but I mean, the point is even about an exponential curve. This is just mathematics. An exponential of x, exponent x, when x is much less than 1, is equal to 1 plus x, which is a linear curve. So it's just basic mathematics. It's actually kind of dangerous to fit an exponential to a very short time scale when you're going to extrapolate that over many times the time constant. Like Humphrey's time constant is 1,400 years. And if you fit your date or take your data, he only used 1970 to 2000. That's what, there's only 30 years. And then from that, an exponential fit to that data, he extrapolates over thousands of years of past time. I mean, you can't do that, you know. But to be fair, his model didn't have any details. Remember his model, he's saying that it was a decaying field from creation, and then there was a big nonlinear effect around the flood, and then it fluctuated and then back into an exponential decay. But I'm saying even his last 2,000 years of exponential decay is you can't make that assumption based on only 30 years of measured data.
Oh, yeah. Okay, those are some good, helpful points. There's a couple of clarifying questions here as well based on your model. I'll get these up, and then we'll shift more into the general age of the Earth questions that I have in order to keep this seminar comprehensive. And so here's a question from Dr. Tapioca Weasel. Can Dr. Hartnett re-explain what he specifically means by the dipole energy?
Yeah, I mean the total energy, integrated energy in the dipole field.
Okay. And Jackson Rowe is asking, is he taking tidal forces and radioactivity into account?
Okay, I looked at tidal effects. I looked at effects on the precession effects. And if you go to my website, one of the articles covers that. I found that so far tidal effects are not significant. And we know the tidal effects of the sun and the moon. These are significant tidal effects. I yet want to model a planetary disk for tidal effects. But if the disk if it's cylindrically symmetric around the rotation axis, there should be no tidal effect other than adding to the bulge, to the oblateness of the planet. Now, I haven't got to model that yet. That's a complex problem. Radioactivity. Look, I haven't taken any of that. When I talked about heat being generated from the core, I wasn't talking about radioactively generated heat. That is happening. What I'm talking about is the energy, total energy being lost from all modes of the magnetic field. So I'm excluding all other heat sources. I'm just talking about the heat generated by the decay of those circulating currents. That's all I'm talking about. You know, with a physicist and a toy model, you can look at selective components. That doesn't say that there aren't these other effects occurring, but they're not important in this case to the angular momentum of the core or its effect on those the turbulent effects in the liquid outer core. But still, yeah, it's a work in progress.
That's good. No,
if Jackson would like to check the math, go to my website. Excuse me. Go to my website, and there's a lot more detail there. I show a lot of the working of calculating the change in inclination of the core. It is a complex problem. The equation I showed can be solved analytically, but not easily. I use Mathematica. I'm not sure if you're aware of Mathematica. It's a you can use symbolic calculations, but you can also do it numerically. And anyway, I did it to an approximation, and then I used the full-blown Mathematica model and got the same result. So even my initial approximation approach was quite accurate.
Well,
but the data I show is the full-blown model.
Well, you've definitely thought through this. That is very clear, Dr. Hartnett. Dr. Tapioca Weasel, follow up based on what you were saying. He's following along in real time here. And
the answer is yes. Yes.
Okay.
The angular momentum of the core is a key consideration. That's the basis of this model.
Well, this is good. Okay, Sam, anything you wanted to add to the second presentation before we move on to a few general age of the Earth questions?
Yeah, I guess regarding the observable rate of decay, can we extrapolate that enough to know how long this planet would sustain life?
Okay, it's a good. Can we put the slides back up again there, Donny? Hello, Donny.
You might have to give him a second. I think he was trying to get some water.
Oh. Yeah, so as I mentioned, extrapolation beyond the data can be precarious, is the word I used. But if we extrapolate the decay, the total energy, or even just looking at the dipole, I mentioned the dates where the dipole goes to zero. Or look, I don't even think that's even a thing worth looking at, because if the energy in the dipole gets down to even 30% or something, and it's equal to the amount of heat that's been generated, then we're in serious trouble, because that means the Earth's magnetic field is failing. And so this is where the long age believer must have a dynamo that regenerates the dipole field. From a biblical creationist point of view, can we just turn the slides back on there, Donny? From a biblical creationist point of view, I mentioned earlier, I would invoke that we need to look at other scriptures when the Bible tells us what's going to happen in the future. And I believe that the Earth is going to be sustained forever. So how does you see the green curve is the total energy in the magnetic field is decreasing in a linear fashion. I think that hits the zero curve around the year 5000. The dipole hits the curve, the linear curve hits zero around 3227. That's the energy in the dipole field. That's the magnetic energy in the dipole. But I don't believe that's going to get to that state, because there's scriptures, and I can support this by scriptures, that the Earth will be sustained forever. And the way that will work is that God suspended some of his sustaining power at the curse. And that's when we saw the energy swapping between dipole and non-dipole modes after the curse. Well, he will reestablish the energy in the dipole field before it gets too serious. So in 2024, they're equal to each other, 29%, and the rest is heat. So that's what, about 40% heat. So God has to reverse the effects of entropy at this point. It has to be reversed so that the dipole field energy is restored and the Earth continues on track. Of course, a lot of other things have to happen too, that God is rebuilding all the damage that is done by the curse in the universe as he builds his new Earth and new heaven and new Earth. That all goes along with the model, which most biblical creationists are fully, well, they don't all believe in exactly that, but certainly they're looking forward to the new heaven and new Earth where God brings back his blessed creation.
Dr. Hartnett, well said. You know, I'm curious, in your in-depth study on this and in the construction of your creation model, which obviously has some good explanatory power, you have remained unconvinced and unpersuaded by the explanations, or what one might call rescue devices, from the opposing side in their attempts to maintain the magnetic field or push it back to where they need to have it, Dr. Hartnett?
Absolutely. I see no reason for it. And I take, as I said, I'm not trying to use science to prove the Bible or the biblical history or the biblical model. What I'm doing is I'm trying to build a model consistent with the biblical narrative, not just timeline, but narrative, that explains everything we observe today. Right. So it's sort of a reverse process, you know. Rescue devices are being used by the long age, I shouldn't just say evolutionists, because some of them are like progressive creationists or you know,
old earth creationists,
whatever. Yeah, the other flavors. Yeah, the various flavors. I don't see that that's even necessary to do that, because it's all based on worldview. It's all based on what you believe, rather than, you know, the only evidence we have that I showed here, we all have it. You know, we all have the same evidence. It's interpretation of that evidence. Now, there are creationists who reject Dodwell's data. Now, Dodwell didn't make those measurements. Dodwell collated them. He collected them. I don't know how many years of his lifetime, but he collected those. And there are some creationists who believe that they're reliable. There are others who have said they're not reliable. But the point I would make, and I made this in the first article I wrote on my blog about this, it's really remarkable to me to see a functional form like that Lorentzian. That's a well-known standard functional form that fits the Dodwell data with incredible residuals and chi-squared tests. If that's just random data, that's just unreliable, bogus stuff from ancient peoples, why does it fit it so well? That's the question you would have to answer. There's something about that that is incredibly, it's quite remarkable, to say the least.
Yeah.
You
know, in your first presentation, I kept thinking that you're making a fantastic teleological argument regardless. And so if we live in a creation that can be rationally understood, and there's harmony and unity between all of those things that provide for that, that's a teleological argument. And I'm not sure how they can get around that other than saying that it's an illusion.
Yeah. But some of it, again, it depends on what flavor of creationist or evolutionist you are, but some of them will admit to a certain level of design, right? And for some, the design is only apparent. Yeah. For some, it's real. For some, it's apparent. So that's also flexible, right? It's like a you choose the amount, or the type you want. You admit to your belief system. Yeah.
Yeah. There's certainly baggage there. I do have one more question about the decay. It's a pretty common assertion that the critics will make. They'll say that the decay isn't actually decaying. We're just experiencing a downturn in an oscillating system that oscillates. They'll extrapolate an oscillation to the past.
Yeah.
But I'm not sure how they get around, the entropic or the principle of decay.
Thermodynamics, entropy. Yeah, well, that's right. So if the magnetic moment data, that's the axial magnetic moment data, if that's even halfway reliable. And it has very large error bars, as you saw. So that in itself is an indication that the researchers are being as fair and honest as they can be, because the error bars are so large. That indicates in the past that the dipole field was not so strong, was quite weak in the past, and it's actually increased. Now, if you're a dynamo guy and you're saying that every, say, I don't know, every 26,000 years or every 52,000 years, based on the Newcomb formula for change in tilt, because some people will use that as some kind of time scale. If you say then that has to be oscillating on that time scale, so it needs to come back up again, and so they would say that you only went back 8,000 years or something. You need to go back 100,000 or 1,000,000 years. Well, yeah. So this all now gets into the arguments of measurements of samples and dating those samples into the past on a uniformitarian timescale.
Here's one from Ray G TV. He's asking, are the dipoles then what we would be seeing as the magnetic field reversals? I know they found those, but would this explain it?
Yeah, so what that means, I try to explain that in the talk. So if you go over the talk again, you may understand what I was saying there. As the energy swaps between the dipole, there's only one dipole, and the non-dipole field modes, like quadrupole, octopole, and so on up, that the energy is shifted in location within the Earth. Well, it's also outside the Earth, but the energy moves around. So the North Pole that we know as the North Pole, magnetic, I'm talking about magnetic North Pole, is moving because the energy is shifting from the dipole energy into the non-dipole modes. The energy is going into those other modes. And then, therefore, when you sum it all together, the vector that defines the magnetic north, that's where the magnetic field is perpendicular to the surface, that moves around. We call that the magnetic north and magnetic south. It's not the geomagnetic north. Geomagnetic north means the north and south pole defined by the dipole, which only, as I said, it only contains 73% of the total energy at the moment. So yes, the answer is we see more moving into the non-dipole modes. That is consistent with possible pole flips. And that's what my graph, a lot of people can't read graphs very well, but if you turn it on again, this in the rectangle, you see the dashed black line represents the energy in the dipole field. That's less than the energy in the non-dipole field when it's above the line, when the blue curve is above the dashed black line. And so that means energy is shifting, or is energy shifted, past tense, during that period of time into the non-dipole field. So, but this is only sampled on a very seldom sample time with very large error bars. So there's no granular structure to it. It's like some kind of an average. You don't see any fine granular. If you could get data for every year, of course, that's impossible to get. You would then see big fluctuations at that time.
Here's a follow-up from, again, Dr. Tapioca. And so he's asking, Dr. Hartnett, how does a linear model reconcile with an observational history with pole reversals, what we're talking about here?
Yeah, well, it's back to that same chart again. If you turn that back on, when I say linear, I mean in the last 1,000 years or something like that, we see a linear decay in the total energy and the dipole, and the linear increase in the non-dipole. So that's what I'm talking about. That so as the dipole energy and the non-dipole energy come closer together, eventually they would be both equal in the year 2014. That's when I think you will have massive reversals occurring. But it could occur before then, because much more energy is into the non-dipole term. And I don't know how much you need to have the field swap where you have the poles shifting, because energy, the octopole is orthogonal to the dipole, for example. The north poles are orthogonal in direction. Octopole is then even more complicated than that. It's a very complex system, very hard to hand wave and explain. But yeah, back in the past, I think the pole reversals do match what I have here in that pink rectangle. The reversals could easily have occurred, and the pink rectangle includes the period of Noah's flood, where Russ Humphreys proposed pole reversals began. All I'm doing is proposing that the energy shift started like that at the curse, and already we had pole reversals and all sorts of energy sloshing backwards and forwards between the dipole and non-dipole modes over thousands of years. So not restricted to the year of the flood and after the flood.
Okay, so when somebody asks this, and I'll try and reiterate a couple of those points and see if I fully understand. So a few comments, but yeah, like this, but at the same time, we're doing it live, so people come in late and maybe don't catch certain things. But someone like Howard F., who says, how do you explain all the evidence from lava flows on land about...
Well, that's the same stuff as we've been talking about.
Right.
The lava flows indicate pole reversals occurred in the past. The big problem, of course, of agreement would be, when did that happen?
When? Yeah.
When? The dates. The when.
And
yeah.
With these two models, you and Dr. Russell Humphreys, him placing them largely at the flood, these rapid reversals, and you, these massive energy shifts and reversals and sloshing back and forth at the curse. So you're placing them in different spots, but still all within 6 to 7,500 years, basically, depending on.
Yeah.
Okay.
Yeah. The only reason I'm pushing back to 7,500 before present is because the data fitting to the ecliptic, the obliquity of the ecliptic, I should say, that data doesn't come from magnetic moment measurements. That comes from obliquity measurements, and the data fit is very tight. It basically gives us that period of the flood. Well, I called it a period of resonance or reaction, because I don't know that that's the flood, but that's certainly the best time for the flood to occur, when you have the maximum change in the tilt, or it's called the inclination of the core axis, and it also coincides with the maximum change in the obliquity or the tilt of the planet's spin axis. These are one-to-one related because of the conservation of angular momentum.
How might a creationist who holds strictly to, let's say, the 6,200 year date for the age of the Earth and universe, how might they interpret that data then?
Yeah, I don't know, because I would say I was largely of that view, though I always allowed for other possibilities within the timescale, of the Septuagint. In fact, many papers I've written, I often said less than 10,000 years. I wasn't going to be too dogmatic. But now that this is arisen, I would add that I think this is compelling evidence unless otherwise shown to be somehow bogus data, which is very hard to understand how such a systematic trend that fits it's a non-trivial curve. A Lorentzian line shape is quite a precise line shape. See, the physics is in the mathematics, or the mathematics describes the physics, the underlying physics. So if you get a curve fitting data like that, you have a problem. You have to explain, well, what's the physics behind it? Why has that occurred? It's not random. It's not some random occurrence. And so if you say, oh, that's unreliable measurement techniques, ancient measurements using a gnomon, it's like a stick looking at the shadow lengths and all these sort of things. If you say that's all unreliable data, well, how do you explain that? How do you explain the precision of the curve fit?
Which would require a physics-based response.
Well, absolutely.
Yeah.
You have to have it. Yeah. You have to explain it based on what the physics is. And then you try to build a model that can explain where that physics came from, how that operates, what's the physical system that is really going on here, or what happened in the past. I keep speaking in the present tense because it's a model, but in actual fact, we're talking about the past. And I can't prove it. I only have data that's, you can't say the magnetic moment data, you can't say that's 100% reliable either, even though they got very large error bars. And then, I showed the Greenland ice core proxy data that fits better to the Dodwell tilt data than does the Newcomb formula based on calculations and observations, of course, of the gravitational effect of the sun and the moon. So it's all a matter of degree, how much what evidence you're going to rely on. In the peer-reviewed publication system, it's what you can get past the reviewers that counts.
So I think those are some good points. I think that was some really good interaction with your model there. And now in relation to the age of the Earth and the topic for this seminar, Dr. Hartnett, the amazing science of young Earth creation, it's been brought up in the chat, and it's typically brought up in debates and discussions on this issue when we put forth these several scientific lines of evidence. I think powerfully point to young Earth creation, as you've done, C14, dinosaur soft tissue, the decaying magnetic field. They'll say, well, we've got such strong data in the rock record itself where, the lower rocks consistently date older than rocks at the top. And there's this nice pattern or order that suggests the Earth is billions of years old. And so that's why they'll say, okay, maybe we have these anomalies or these harder to explain pieces of evidence. But in light of that pattern that I just described, there's got to be an answer that fits within the millions and billions of years paradigm. Now, I understand there's a lot of different answers from creationists to that challenge. I'm curious, Dr. Hartnett, what do you believe is the best way or answer to that argument?
Well, there are many inconsistent measurements to that idea. There are many mountains sitting on top of strata that is younger than the mountain, and yet it's supposed to be the other way around, right? You're talking about a systematic trend of deeper is older. Deeper is older. Yeah, get the right way around. But there are many counter arguments. it depends on what you look at. Radioactive decay processes, for example. You can look at, say, a single sample of a rock bearing, say, 3 different radioactive decay pathways, and they all give different ages for the same sample. And the ages vary by billions of years, not by some 100 years or something, by an enormous amount. Then there's other lines of argument where they talk about constant decay rates. But we know, and in the past, maybe in physics in the past, it was believed that nuclear processes cannot be affected by external environments like chemical environments and things like that. But that's all been overturned.
Right.
Yeah, the matrix in which an atom resides or the chemical environment, these actually affect nuclear decay rates. So some of the fundamental assumptions easily overturned nowadays. So I have no problem looking at these things. And if you have a decay process that has a time constant of 1 billion years, you say uranium or something, then you naturally will get from those assumptions ages of the order of the time constant. But that doesn't mean that rock has been decaying over those billions of years, because you don't know what the parent to daughter ratios were in the beginning. And there's no way you can know, it's impossible. You could go on, and I'm sure creationists have covered these sort of issues for a very long time. And I don't find any scientific argument that would change my mind about the age of the Earth based on the biblical timeline.
Right. And so I'm kind of curious then, because I've seen different answers depending on what creationists you ask and what flood model they hold to, or various other views on young Earth creation. And so, okay, we get these discordant dates, that's for sure. They'll look to isochron dating and say that removes some of the assumptions, but I've read papers from Dr. Andrew Snelling where he's still shown false isochrons or discordant dates. So that doesn't save the day for them. But so I'm wondering, from a creationist starting point, then we get discordant dates. Clearly these methods are largely unreliable, but we still get millions and billions of years. So now how would we explain, like, at creation, for example, did God create rocks with a mixture of elements, some uranium, some lead? I'm curious, what would be a good view of that, Dr. Hartnett?
Yeah, I would say it's the same we see through the whole universe, that at creation, God created the universe approximately like we observe it today. So that means the mixture of elements, the radioactive isotope ratios, we see the same in the stars, in the sun. All these things were created essentially in the proportions that we observe today. There's been very little time passed for most radioactive decay processes for anything much to change. And so if you make the assumption that, the sample began as some pure element A and decayed into element B, therefore, and the time constant you measure today in the lab is 1 billion years, then you're saying it has to be billions of years old. That is unprovable. I say that God simply made a mixture of everything, and that's what we observe today.
Yeah, God made Adam with the appearance of age, and it seems like he would have to make forests with plants in different states of, if you're going to have an ecosystem, you've got to have young ones and old ones decaying for fertilization.
Okay,
and
so I'm sorry, go ahead, Dr.
The fossilization argument is another bogus claim. I deal with this in my book. You have to deal with it in 2 sections. Section 1 is hydrocarbons not including coal. So we're dealing with the hydrocarbons of the gases, the alkane mixtures, liquid petroleum, and so on. This is primordial. This is natural to the earth. It's part of the creation. God created it. if you were to say that those gases and petroleum and so on are from past biological activity of some kind, you have a real problem, because the solar system is full of that stuff. You know, you got methane oceans on Titan and various things like that. But the evidence is that petroleum and natural gas, methane, is cooked up in the earth from carbonates and iron oxides and water under temperature and pressure. And this is an ongoing providential provision by God. It's for supply of humanity. It's something God providentially foresaw. And that fits all the data. The chemical experiments, the measurements, those have been done in a lab to produce methane from that process.
Wow.
Then dealing with coal is a different process altogether. And coal, it seems, comes in forms where we see coalified trees, tree roots. We see these processes can be reproduced in the lab under high temperature and pressure. So that is a fossilization process that occurs. But we found it can occur rapidly. Rapid burial, rapid coalification does not need millions of years. So those lines of evidence, as far as I can see, they are for old Earth dating or old Earth arguments, evolutionary arguments even, they're no longer tenable.
That's right. That's right. Regardless of the feature that they say requires millions to billions of years, oil, natural gas, coal, even limestone. We've done programs on limestone. The rock strata, it's all been observed. We have good reasonable evidence for that being created quickly. And so I was kind of curious, going back to what we were talking about with God initially creating a variety of animals, plants. In genetics, we would say God created Adam and Eve with pre-existing DNA diversity. And so you were saying then, Dr. Hartnett, that when it comes to the original rocks, the composition of these original rocks, he would have also created them with a variety of uranium and lead, mixtures of ratios, basically.
Exactly.
Okay,
That's
so then hypothetically, if scientists were to come along an hour after creation, trying to get a good picture in my mind, and they were to do dating methods, they would subject these creation rocks to dating methods. Would they then get false dates, billions of years? If those ratios are there, they're going to assume the lead came from uranium, even though it didn't.
I don't see it like it makes any difference on when you do it.
Yeah.
You'll get, if your initial assumptions are wrong, then you'll get the wrong date. You know, that's a fact. Yeah.
Then why, I'm curious, if a creationist were to ask, okay, if that's the case, why do we necessarily need, because I know a point that we bring up is that those in the conventional world, they assume a constant rate of decay. And therefore, we as creationists might say that nuclear decay was accelerated or sped up in the past. But why is that necessary? Because then critics just say, okay, fine, you can have decay rates sped up, but now what do you have? Excess heat, energy, radiation, which is just going to cook the earth. So do we really have to go to the accelerated decay argument, Dr. Hartnett?
I don't know if we do. I know the rate team worked, one aspect of it worked on that. And there is some of the evidence was quite compelling, but I don't know if it's even necessary, because it's the same old problem that we have. Everything we're doing is in the present, and we're trying to construct models of what happened in the past. We are subject to the same limitations that anyone else is subject to. I'm first in line to recognize those limitations, but that doesn't change my mind about the age of the earth or rocks or anything. So, you know, I think having diversity of opinion, excuse me, amongst creationists is a good idea.
Yeah.
It's good to have those different views, different arguments.
Well, it's healthy. It's how we grow. It's how we model build. Multiple working hypotheses are and can be good. Sam, did you have a follow-up question? Oh, did Dr. Hartnett? Go ahead.
I was just going to say that the counter argument is a dangerous one, to think you've locked it all down to the model.
Right. Yeah.
And
one model.
Yeah, it's no good.
Because then everything falls on that model. And so, in the world of accelerated decay, okay, possibly, because then you do have the existence of, the helium and zircon crystals and radio halos, fission tracks. But if that's the only model, like you said, the model, but we don't currently have a persuasive answer. I'm not saying we don't, but I'm just saying some might say, well, we haven't really solved the heat or radiation problem.
Yeah.
Well, now we're just stuck with that model then. So I think multiple working hypotheses is beneficial, you'd say, Dr. Hartnett?
Yeah. And maybe some truth comes from different models too, It may not be so homogeneous. It may be a heterogeneous mixture of different models, different times. We don't know. The hand of God it has been operating in our history. We can't say it hasn't.
Yeah, so I kind of have a question about, so we've talked about throughout this whole conversation that we have for part 1 and part 2, how there is fluctuations that they'll invoke, fluctuations and potential contaminations when it comes to a decay of these radioisotopes or whatever it might be, and with the field that we talked about. And it just seems like if one of their foundational assumptions is uniformity, but when there's a problem on their model, they have to turn to I guess, dispute that uniformity. How does that not affect their extrapolations into the past? If the uniformity of nature is real, then it seems like from a physics perspective, you can extrapolate that back all the way to a singularity, whatever, on their model.
Yeah.
But if it's more of an illusion and it's not as secure as they would say, how is that not a problem?
It is a problem. You're right. It's the old problem of measurements in the past. Punctuated equilibrium model, happened so fast you couldn't see it, or happened so slow you can't see it. It's got to be just right, not too hot, not too cold, somewhere in the middle. No, it's a problem.
I have to put this up to make it complete, because this is always brought up. We have addressed this in the past, but it's one of the critics' favorite responses, specifically to the C14 we discussed earlier. And so they'll say, rather than, in my opinion, providing a good answer for why we find C14 basically anywhere you look in the geologic column, instead of providing a good answer to that, they'll just say, well, okay, but the dates you get, 70,000 years, 45,000 years, I think it was, consistently with coal, tens of thousands of years. They'll say, okay, but that's not 6,000, that's not 7,000. So to them, that's refuting young Earth creation. So I guess my question to you, Dr. Hartnett, why aren't we getting dates of 6,000 to 7,000 years?
It's because it's a circular argument they're making. They're assuming evolutionary assumptions, which means for carbon-14 means the same ratio at the depth of the sample, and when we measure it today, that it's not accumulating, it's constant in the atmosphere, it's a closed system, all the same examples. Decay rates are constant. So that circular argument, that's assuming the evolutionary worldview to be true, to prove that it's true. And then if you get a date that's discordant with that, you say it's something else. But yeah, so any dates less than 70,000 years, because the accelerator mass spectrometers can measure isotope ratios out to 90,000 years. Any dates less than that defy the evolutionary model. They have to be millions and billions of years.
Yeah, and before the flood year, the ratio would have been different, correct, Dr. Hartnett, on C14 and so
Yes, before the flood, yes, for
before
sure.
Okay, so if the C14 is produced by cosmic rays essentially striking nitrogen atoms in the atmosphere, then isn't that going to, from creation to the flood and after, that's going to build up over time?
Yes.
And so like you're
that's right.
saying, they're making false assumptions here. And so
Yeah.
they're thinking, well, the 70,000 years, that's an absolute age. Rather, we'd say it's relative. There's a reason why we're not getting exactly 6,000 to 7,000, but we're definitely not getting this C14 shouldn't even be there if the Earth is billions of years old.
That's right. And we don't know what the Earth's magnetic field was exactly. I mean, what the graph I showed you actually had it lower in the dipole field, but when you sum them together, the total energy was higher and slightly decaying. Now, what effect does that have on the shield, the magnetic shield, and therefore cosmic rays causing carbon-14? We don't know totally what effects that has, because it means a weakening in the dipole field, therefore a weakening in the shielding at the north and south poles, and more cosmic ray particles coming in. Now they can come in from any direction, but obviously most will come in where the field is weakest. We don't know exactly what those effects are. We can generally say the magnetic field was higher in the past. That makes sense. The total field I'm talking about. But what effect that has on C14 creation. And another effect is the burying of all the carbon-12 biomass in the flood. How does that affect that ratio?
And
look, there's another unknown in all this too, and it's the sustaining power of God, the providential protection that God had in the post-curse world. Because we say God cursed the universe, but he didn't curse it to the point that it just wiped out all life, and so he has sustained it. So did he sustain it with the Earth's magnetic field too? Did he, did he keep it up to a certain level? Because these are really, these are at time periods are very hard to quantify what the level of it was and what the accumulation rate was. What was the cosmic ray bombardment at that time?
Yeah.
I don't know. It has to be assumed today. By assuming carbon-14 to carbon-12 ratio is the same, you are saying that it's the same. You're saying it's never changed.
Yeah.
So I don't know how you can make those claims personally. And then the 6,000 years or the 7,000 or 8,000 years or whatever the date is that I mentioned for the diamonds and the coal and so on, that's making those other assumptions that the carbon, the big one is carbon-14 to 12 has been accumulating. That's one of the big creationist assumptions, that it's not constant and it's accumulating, and therefore that will skew your dates, because you started out at a lower ratio for your non-existent blank, but in the samples that are the freshly interred samples, the carbon-14 to 12 ratio may be less than it is today. So what does that tell you? If you make that calculation, that would tell you it's younger than it once was. I think there are mollusk shells where you can measure the ratio in their shell, and you actually get a date that they're not even dead. Because it's the opposite sign, so you get a future date and not a past date. there are a lot of anomalies even in this, you know.
Yeah, I think they did that with a snail shell recently.
Was it?
Yeah,
Was it a living snail shell?
I believe it was. I believe it was.
So the argument is it must be dead.
They can
Right.
fact check me. Yeah, that it died
Yeah.
quite some time ago.
Yeah.
You know, when we look at their explanation of the geological column, you have all of these layers of strata, and
Yeah.
their explanation for each layer of strata was a drastic change within the environment that caused the new layer laying down.
That's
And we
right.
don't know the cause of that or the effect of that. And
Yeah.
because they'll represent those layers as numerous layers, that is the opposite of uniformitarianism.
Terranism. Yeah.
So it seems like there's a gross contradiction there within their belief sets.
Yeah.
Which is it?
Well,
And
on that point, I recall visiting Grand Canyon with John Baumgartner many years ago. I think it was him. I think it was. And no, it was Russ Humphreys. Sorry, Russ Humphreys. And they were videoing it. And Russ was pointing out this particular layer. I can't remember the names of the layers. I'm not a geologist. And he was talking about these very, very sharp breaks or edges between the layers. And that the certain layer below another layer is 10 million years older than the layer above it. But the sample in between is like 20 million years. So in other words, you have 10 million years of time pass, and then in this layer that's only a few grains of sand thick, you have 20 million years pass, and then you have another 10 million years. And it's sort of like, it's like slow and gradual, and then you have rapid deposition, and then slow and gradual and rapid deposition. And that really struck me when I was there that time. It's just a story. The story is made up to match whatever is found. They have to match the story in. So you have slow and gradual at times, and you'll have rapid catastrophic at other times. And the evidence for it, it's what we observe. That's the evidence. Yeah, erosion surfaces. Someone has commented, that's right. There were no erosion surfaces between these very sharp layers. They're almost non-existent erosion surfaces. And so, I mean, that's even more stark in that whole situation.
Some of the critics in the chat on the C14 are saying, well, the 70,000 that we get for the C14 in these samples, that's just background radiation. That's what you would expect for the background radiation.
No, it's not, because of the various techniques I mentioned. The accelerator mass spectrometer can actually measure even just a bundle of a few atoms.
Yeah.
So there's no background. That's the whole point. That by cutting the sample down and get the purest sample uncontaminated as possible and measure only a few atoms, you eliminate background contamination.
Well, they have to preserve their paradigm at all costs, brothers. Now, here's the thing, Dr. Hartnett. We could ask you questions all day and night. We could ask you questions till same time tomorrow, but you've already given us so much of your time, and you've been so gracious with your time, not only for the program itself, but the work that you put into those two epic, I would say, very thought-provoking and informative presentations. Perhaps the next, well, I'll say this to those in the chat, looking for a distant starlight discussion and some more discussion on astronomy related topics. We did discuss that, I would say, in pretty good detail, Dr. Hartnett, in our first program.
Yeah.
And so people could check that out. And also, a future program, we could dig deeper into that as well. But looking at the time, Dr. Hartnett, I don't want to keep you any longer. So you've done a great job tonight. This has been a lot of fun. Tonight for us, it's morning for you, right? You're in the future?
It's just after lunch.
There, well, you've earned yourself some lunch, because if it's after lunch, you've done this through lunch, brother. So let's throw it to you. I really appreciate you doing this. It's a great idea that we took both parts and combined them into one massive must-watch 4-hour seminar on the amazing science of young Earth creation. I think we were comprehensive. We interacted with our chat. We addressed objections. Hopefully, we've planted some seeds, because, brothers, we could win arguments all day. It's about winning souls, planting seeds, bringing people to the truth. So, Dr. Hartnett, let's hand it to you. Give you the floor if you had any final thoughts, final words, anything you wanted to leave us with here tonight for this seminar.
Well, thanks, Donny. Thanks, Sam. It's been great. Thank everyone for listening. And if you want to follow up on my model, go to my website, BibleScienceForum.com. There are many articles there.
And there it is. Yep. No, it's our pleasure. You put a lot of work into this, clearly, Dr. Hartnett, and this was very edifying. I've been looking forward to it, and you did not disappoint. So for those that want to see more from Dr. John Hartnett, I highly recommend it. I've spent a lot of time on it. Check right here, a link, BibleScienceForum.com. Check the description box of this video for additional links. And of course, before closing, Sam, my award-winning co-host, brother, appreciate you doing this. I hope you had as much fun as I did. Let's hand it to you for some final words, final thoughts.
Yeah, Donny, thanks for having me on. Dr. John, it's been a joy to spend my Saturday night with you and everyone else in the chat, especially the critics, hanging out with us Christians, talking about God on a Saturday night. We're praying for you. There's still hope. And so thank you. Thank you, gentlemen.
Thank you, Sam. Okay. I enjoyed this. For those, just tuning in, we're going to wrap things up. Go back, watch it right from the beginning. Again, there's been 2 parts here. Part 2 was John's model. Excellent presentation. Part 1 focused on several truly incredible lines of evidence for young Earth creation. We had extensive Q&A periods after both presentations. So do go check that out. And please share it around with your friends, share it around to your family. If you're not yet subscribed, hit that subscribe button, and share it around on Facebook, share it around in groups. Let's get people talking. It's important. So with that, God bless you all. Thanks for tuning in. Stand for Truth is out.